Hello. Let's get started with the afternoon session. So in the afternoon, we will have three amazing sessions on agent applications, foundations of agents, and AI safety alignment and security. By the way, I'm Jing Xuan. I'm the session chairs for the afternoon. I'm a postdoc working with Professor Dong Song. So our first session will be about agent applications. And the first speaker is Deepak Agrawal. Is Deepak here? Yeah. Deepak is a Chief AI Officer at LinkedIn. So the stage is yours.
Everyone, so happy to be here to kick off session 3 with you. I'm not Deepak, as you can see, but he did ask me to come here in his place. My name is Adam Kaplan. I'm a senior staff engineer at LinkedIn. I work on Agents platform, which is part of Core AI, where I work with Deepak on the future of autonomous agents. So just a quick sidebar. Why LinkedIn? Why am I here? LinkedIn's vision is to create economic opportunity for every member of the global workforce. And we believe that we can't do this at this point without agents to help workers unlock value by getting their work done more efficiently. So I promise this is not a producty thing, but bear with me for a minute. There is a point. Late last year, we launched something called Hiring Assistant, which is a multi-agent product that's targeted toward recruiters, so probably nobody here has used it. This is not the target demographic. But this is a system which uses 4 agents with a supervisor agent, kind of a common pattern. I know everyone here is probably familiar with it because I saw that in the previous talks, hands were raised. Like pretty much everyone has designed a multi-agent system here. Well, as pre-work, we start out with a preference model that's constructed by analyzing the recruiter's decisions and actions made in past projects and current projects so that the agents can be personalized to a particular recruiter. And so these 4 agents here, the first intake agent, that's helping the recruiter get through the workflow of creating these roles and job descriptions. The sourcing agent goes and finds a huge list of candidates. The evaluation agent helps you hone in, helps the recruiter hone in on the best candidates. An outreach agent actually initiates that initial communication to the candidates in a way that's personalized to the candidate and the recruiter. So this system is supported by a deep ecosystem of tech stack that consists of like open source and sort of where there are gaps in the open source ecosystem, some home-rolled technologies. So why am I talking about this besides to show that we're doing cool stuff? Hiring Agent was shipped in October. That's a multi-agent system delivering value to our recruiter customers for months now, and the reviews are that they're getting significant positive impact. So when we talk about the frontier, this is the frontier stage. Multi-agent systems certainly are the frontier, but I feel like this is like a crashing wave at this point, not a cresting wave. So when we're standing on this frontier and looking forward, I mix my metaphors here around the curve, but when we're looking forward, we see autonomous agents rising in importance. And these 2 things are linked, right? And I'll get to some of that in a moment. So what is an autonomous agent, at least by my definition of an autonomous agent, is an agent that starts to take in multiple signals from its environment and use those signals along with its memory to orient itself. And then we go into the typical like React loop that you can see there on the right side, reason about the next best action, take that action with a tool, incorporate the feedback, and on and on. So it's a subtle difference, but very impactful by taking in multiple signals. We're going to get into a bunch of interesting problems that I want to talk to you about here. The first one is memory. Okay, so again, this is a typical memory stack that you might end up with if you're designing an agent within a multi-agent system or not today. You have roughly 3 tiers of memory. The first is your in-session memory. This is your active conversation, messages that the user sent, what you sent to the message, tool calls you made, results from those tool calls. Very high resolution. The second tier, when you have too much of that conversation, is summarizing that history along some axis of classification. If it's like a ChatGPT where you click new chat each time, then there's your classification right there. You summarize each of those, and now you have, in your context, you have the broad strokes of what you've done and the learnings and takeaways from that. When you have too many tasks that have been summarized, now we move back one step further, break everything down into primitives, facts, phrases, shove them in some retrieval system, EBR, or if you want to be fancy, maybe something that's powered by an agent, or maybe a combination of those two, and use it for RAG. So with an autonomous agent, it starts to look a little bit more like this. If you can take in multiple signals at once, and I'm talking about a specific agent here. I'm not talking about everyone's individual agent, right? So those signals can come from two different users. So now we end up with these two isolated memory stacks. They're isolated because people expect that. There's a certain lack of trust we all have right now, everyone in the world, with agents. And part of that, part of getting around that involves us assuring people that when they say something to their agent, it's not going to be repeated back to another person or otherwise, leaked across boundaries. But this presents a pretty big problem, and it was touched on in some of the morning session 1 talks. Take a straw example. If we have an autonomous agent named Evie who is working with a user named, let's say, Jane, to plan an event, it's an event coordinator agent, and it's working on setting up all the logistics for something like this conference. And then we have another person, John, who's aware of that whole setup and reaches out to Evie and tells that agent, hey, we're going to need 10 more rooms or something. What is that agent supposed to do? In the current scenario, the naive context, it's probably going to start to reach out to the hotel, let's say, I mean, if that was possible. And that can cause confusion because now you have not one single point of contact for that making those decisions. So the way around that is to introduce another type of knowledge, which I'll call here common knowledge, for that agent, within that agent, where it's aware of at least what it's doing in other contexts, if not just enough information so that Evie would know that it shouldn't take an action. It should probably tell Jane that there was this change, and maybe we incorporate that information into the main task loop instead of forking somewhere and causing chaos. So how do you get things into common memory? We're working on it. That's about all I can say there. It's a big one to solve because the concerns that you would have with this are very broad. There's trust concerns between those two users. If you're in a company, which is likely where this would be happening, there's regulatory concerns about data being shared, like DMCA and things like that come into effect. There's policy concerns from the enterprise administrators. Lots of things that need to be worked through. And then there's the basic human expectations of what is appropriate to be shared. But I think we can solve this. And the reason I think we can solve this, and first of all, we need to solve this, because if we don't solve this, our agents are stuck in boxes, and it's going to be a pretty lame next 2 years. The reason I think that we can solve this is because human memory, we usually experience human memory through language. There's actions that you take, but I think that's not really the analogy we use, because if somebody forgets how to use a spoon, we consider that a debilitating illness, right? That's not what we're talking about here. We're talking about how people make decisions about what memory is appropriate of their memory is appropriate to use in what context, and how to let it decay, in these tiers, how to let it decay in this sort of expected fashion. If you can't remember what type of pencil you used to take notes 2 years ago, nobody thinks that's a problem. It's a feature of the system. So because we can express those limitations and boundaries in language, I think that starts to look a little bit more like the reasoning problem. Once we were able to express reasoning through language, we could attack it with the models. Oh, that's something that I'd like to see happen here, and it's pretty important for us. The next place that I want to go is to talk about our modular agentic architecture and how it's essentially come together in practice. So We start here with our sort of typical React loop that I showed in the beginning with an additional box here in the top labeled tool discovery. So the tool discovery is meant to help the autonomous agent explore its environment. So with specialized agents, you tend to have not much agency. There's a few tools that they have. There's a sort of predefined workflow that they're operating in with set decision points. And they make decisions, the LM's making the decisions, but where it goes is kind of controlled. When you have the more autonomous agent, it has a larger set of tools available to it, just by definition, because you're doing the work of multiple smaller agents. 2 years ago, I think maybe 10 tools was the guidance that you can realistically put into an LM. Last year was 30, this year with O3, we're at 100 for that particular model. Great progress, 10x in a year and a half or so, but the amount of tools is 1,000x since then. And we see things like MCP on the scene, providing this fabric that allows existing APIs to communicate their capabilities as tools to LLMs more efficiently than ever before. So there is an explosion of tools. Tool discovery is going to be with us for some time now, for some time yet. Yeah, I'll leave it there. Now, ACT, tool calling. When you have the more autonomous agent where you're not, you're not planning every single action that the agent takes, you will quickly realize that there are two classes of tools. Idempotent tools like knowledge retrieval that are fine, you just use them. That's maybe like 10 or 20% of your tools. And the other 80% are destructive, potentially destructive tools. Sending an email, they're all like communication-y, right? Sending an email, committing code is communication. Sharing a doc, commenting on a document, or like planning an event. So these things, because they start looking like communication, we found that we have to treat them the same way we treat messages sent to the user. So we have safety validations on the parameters that go into the tool to make sure that they're not hallucinated, that they're appropriate, and things like that. Similarly, when we get feedback back from the tool, we don't just stuff it in the context. We first have to do semantic jailbreaking and other checks, static and model checks, because once data goes into the context, it becomes very difficult to take it out. You might get saved by, if you're in Azure, by their content filter, for example. But then what do? It's hard to back off an agent that's working on a long-running task to get back to a state where you can actually like execute safely, because there might have been tool calls that happened in the middle that you can't forget. So both of the feedbacks from the tool safety and the jailbreak are communicated, both of the validation feedbacks are communicated as tool feedback so that the autonomous agent can reason about what happened and make a decision. For example, maybe it goes and tries to find another tool, or maybe it changes the parameters it uses, comes up with a novel way to reach a conclusion, or gives up. And the last thing that I'll talk about here that we found becomes very important is that there is not enough GPU, right? Okay, so reasoning models are great, and you can make some amazing experiences quickly with them, but you can't scale them. So what we found is that there are a pretty significant amount of user requests that come in, which can be satisfied by the existing context. You don't need tool calls. Your basic, like if I asked the agent what its name was, or whatever, something like that, which it just needs to reference in the current context and respond back in a coherent way. We use a completion model for that. So by doing complexity classification, we can move work off of the slow, expensive reasoning models onto the faster, lower latency completion models, and let our reasoning models spend more time on the harder problems. So in essence, what I want to just leave you all with is that main takeaway that I've had after working towards autonomous agents for the past 2 years now is that if you set out to bend the human expectations in the human world to the agentic world, you're not going to succeed. The way forward here is to take the agents and take the systems that we're building and adapt them to the human shape. This world is designed for humans. Everything about it, the expectations, the communications, the way we work, is designed for humans, and that's what we adapt to. So, I mean, my last minute, like a something that I've been thinking about recently around trust. It's like people expect the model to be perfect, never leak info. Okay, when you hire someone, you onboard them into your organization and give them the keys. And why do you expect them not to exfiltrate all your data? If we can understand the behavioral psychology of that and figure out how to adapt our agents to that, to build the infrastructure for them to conform to that, I think we're going to be very successful. So thank you. That's all I have for you.
Our next speaker will be Alu Trivedi. So Alu is head of Gen AI at Oracle Health HDI.
Hello, everyone. I am Anu Sua. I go by Anu. So today I'm going to start about talking a little bit about myself and then about Oracle Health. About myself, I'm a computer scientist who had a lot of passion about health and healthcare. Started as a researcher in VA Hospital, worked in Texas Advanced Supercomputing Lab on genomic resources, and then worked in Microsoft Research for almost 10 years, AI for Healthcare, then AI for Good Research Lab. Got burnt out by failure of healthcare in COVID, moved to e-commerce for 3 years, but then couldn't stay away, and back again doing healthcare for AI. So that's a little bit about myself. So you know, it's a deep-seated passion, which basically brings out the researcher in me. Now a little bit about Oracle Health. Most of the people I met today were really surprised what Oracle is doing in healthcare. So there are two large EMR systems in the US, Epic and Cerner. Oracle acquired Cerner back in 2021. It was one of the largest acquisitions by Oracle. And now, as a result, we own almost half the patient population's data in Oracle. That's a lot of responsibility, and we want to bring a lot of impact onto our patient lives through the applications of AI. And thus, I'm here kind of trying to do that. So just to iterate a little bit about the need for automating the healthcare system. Just to lay out the land, how the impact of a patient's life goes through a full circle. There's a provider, the hospital systems, or the clinicians who are working regularly, meeting with us, trying to help improve us. There are payers, the insurance, who support us and get treated in the right manner. There is a lot of analytics which goes into how our insurance is distributed, how our providers can or cannot treat ourselves. And then there is pharma and life sciences, where there are new drugs constantly coming out, trying to figure out, hey, how is a patient's life safely treated? Now, connecting all these various different domains and all these different varied KPIs or success of metric is very different. Providers want to keep as many of the patients into the system as possible. Payers out, do not want to keep them in the system. So how do you kind of build these generic systems? It's not the job of a single foundational model. That's come the agentic frontier, like the next generation agents, where it's a combination of different tools, not just of a foundational LLM model to bring all these different various aspects to treat a patient's life. Now, some of the applications that Oracle is working on is accelerate the discovery and development of new insights and therapies. Imagine in your EHR, your provider can start seeing an ethical ad to start saying, hey, this drug is not safe for this particular cohort of patients if you have this comorbidity. How useful it will be if you can be recommended to a forward-looking therapy for an oncology or cancer, which there is no drug known today, right? So those are some of the cutting-edge things where life science and provider systems can definitely get married into to solve. There are clinicians engaging with patients and clinical trials. So when you go and visit a clinician, most of the time, they turn away from you and they're just typing and taking notes. How good it will be if you can automate the data extraction from the communication between the patient and the physician and automatically populate the EHR systems, because at the end of the day, that's what most of the systems like Scribe do. So if you can do that in an ethical and private and secure manner, it would give the physician more time to have that direct patient communication and focus on the patient rather than taking the administrative notes. Deliver insight and therapies into hands of clinicians, as I just said, right? Figuring out for oncology patients how to basically make all of these trials and therapies accessible to all. So now comes the agentic piece, right? Why agentic AI in health and life sciences? So healthcare data is extremely unstructured and noisy, and there's a high cost of error for any predictive model. It could be basically cost of a patient's life. So there is very low margin of error that we are working with. Now, and continuously shifting objectives. Some of our colleagues are essentially just medical informatics folks who are working years and years as an RN or in companies with 3M Medical and just works on evolving codes and concept IDs to map diseases and all of these things, right? So there's a lot of shifting objectives. Every year, these codes keep on changing. How do you make sure that the treatment plan a care manager or physician is developing for a patient does not fall out of insurance and the patient is not thrown out? So that is the major goal for us to bring healthcare for everybody. Now, agentic AI keeps us honest in the continuous spanning phase. A lot of tool execution reduces the dependency on just LLMs. And there is, of course, the reinforcement learning, which is a self-correction piece, which helps bridge the decision support, automation, and reasoning. So today, we're just moving from assistants to autonomous collaborators. If you remember, this is something which, the AI godfather, Geoffrey Hinton, said, healthcare is the only place where if you throw tons of autonomous agents, it will keep imbibing without affecting any human workforce because there's so much lack of human workforce and knowledge in this space. So the AI user experience patterns for pop health and life sciences, we are trying to divide it up into two large sections. One is a deep research agent, another is the agentic fleet. The deep research agent, think about it as your analytics consultant, where they anticipate the questions, they embed the workflows for personas across different pop health and life sciences. Your quality manager's workflow is very different from your clinical care manager's workflow, from your physician's workflow. These are different personas coming at different stages of your treatment plan and trying to do different tasks. And this whole end-to-end scenario is what delivering a good healthcare to you. Trying to understand the tasks for those personas and planning accordingly is what the deep research agent's major focus is. And the agentic fleet, think of it as more autonomous tasks happening in the back end, where the agents are driving seamless actions across different cohorts of patients, different campaigns to be launched for different diabetic patients versus COPD patients. Always on monitoring patients, figuring out the adverse events for a drug safety, right? So these are all autonomous agents continuously running in the background as agentic fleet, continuously communicating with each other. So if I'm to break out the components of the AI pattern here, this is how the flow would look like. A deep reasoning agent, somebody can come and ask and get informed and understands the evidence and the data, and then basically informs or delegates the task to the agentic fleet, where the agentic fleet is taking autonomous action, providing assistance, monitoring and triaging the right cohort of patient to the right problem space. And all of these steps are eventually creating high-quality curated data at the back end that you can continuously keep on ingesting, extracting, and normalizing to provide that evidence of support. Because that is what we are lacking in healthcare from the noisy, unstructured data. We have to focus on basing our thoughts. So if I'm to define what a health frontier agent could look like, it would be a mixture of primitives. What is a mixture of primitives? The deep research agent, the autonomous fleet that I just spoke about. If basically we can define it as a mixture of primitives combining basic agent-based or tool-based building blocks. And when the primitives are leveraged correctly, we see a highly emergent order behavior, right? You can have a base LLM, you can keep on tuning it, and then you can have your actions like planning, semantic search, simulation, which is basically now delegating all these agents to do all the tasks. Some examples, as I mentioned, the digital care manager, trial matching to do like site visibility and recruitment of patients, safety agents like for adverse drugs. The digital care manager usually, just to give you an example, is like usually sits in between the patient and the physician. To give you an idea about how less percentage of our patients gets it, it's only 1% of extremely ill patients have care managers. What if we can create digital copies of this care manager to scale and benefit every patient? This is an example of a deep research agent where it has basically gone and collected the real world evidence and started generating this dashboard. It is actually trying to get you the trial cost. It had done some market analysis and predicted your time to market for your drug, expected your trial duration, cost of the subject, all of the breakdown. Now, you can ask a question why certain trial design suggestions have been made. For example, why certain cohort of patients were excluded from this design of the trial study. From there, it will go and kind of try to rationalize that patients with liver cirrhosis are excluded from this phase 2 trial study because of some safety concerns, and it can go on to produce a detailed report for you. So some of the lessons learned is tools are mandatory. We definitely need an auditable planning. Modular monthly agent workflows helps you evaluate your tasks better. Hybrid decisioning is something which is coming more and more on board. And the state and the context continuity is ever important. Some of the guiding tenets, we need meaningful evals versus abstract measures. Results as a service is autonomously solving the problems. Flexibility to use the best in class as they evolve versus locking down into a single LLM or a framework. Providing the right size for the complexity, expecting as many builders as you kind of make your task more and more complex. And uncompromising on safety and resilience, privacy and security, trustworthiness, and transparency. Lastly, we're hiring, so feel free to reach out and help us build this together. Thank you.
Thank you, Alu. Next speaker will be Ashutosh Nema, who's a consultant of data science at Dell Technologies.
Hello, everyone. I'm Ashutosh Nema, consultant data science at Dell Technology, where I lead design and development of Gen AI systems at scale. The topic that we are going to cover today is from hype to impact, right? And it's a bit different than the topics that we have covered till now of agentic application. It's more about how do you bring agentic applications to scale or to production, right? Because it's all the hype right now, but getting it to production is what's the difficult task. So starting with the market, right? We have seen, we are all live breathing Gen AI evolution day in, day out, right? We see models coming in, research coming in almost on a daily basis. It's hard to keep a track of what's going on, and so is for industry, right? Industry struggles with legacy systems, with all of the data problems and all of those things, right? One of the survey that was conducted by Big Fours, right? What that led us to is 95% of the companies and Gen AI leaders are talking about bringing Agentic and Gen AI into the companies, but only, if you see on an average, only 20 POCs make it, right? And within those 20 POCs, only 30% of it graduates to production. So what's causing this lag, right? The research further suggested that strategic misalignment is what's causing it, right? So when we think of Gen AI or agentic systems, we think from a shiny perspective, but we fail to miss the mark of is it actually adding the business value or impact, right? Is it actually usable towards the end goal? But regardless of that, wherever that makes a green light or wherever it's able to go to production, you can see that it's a net positive, right? So the path or the goal at the end of agentic system is clear, that there is value out of it, but what are the roadblocks and how do we navigate it? So if you see current challenges that are in agentic adoptions, right? There are strategy and operational challenges, which as I stated before, with strategy misalignment, but also with matrix stride flow, right? Currently model, if you have a machine learning model in production, it's being monitored by business day in, day out. There is a KPI attached to it. You cannot miss that mark any day. So those are the business constraints that are in there, right? Companies are struggling with, should we build versus buy, right? That's a big discussion going on right now. Everybody thinks, should we do this POC or should we buy it? From a developer and user perspective, as the technology is growing, nobody can call themselves a master of agentic AI at this point, right? We don't even know what's going to come out tomorrow. So there is definitely a skill gap, even with the pros. And at the same time, we have legacy systems, legacy data. It's hard to move those bottlenecks sooner at the rate at which the technology is advancing, right? Now, with Gen AI, there is a huge difference between the pilot and production phase, right? As the users are evolving, everybody is using Gen AI, getting used to it, there's a huge gap. So let's say, for example, we tested out a search bar which could go to a product page, like you have it at Amazon, right? Before the reviews, you could just go and search anything related to that product at that product page. We tried doing that, and add a fancy Gen AI-enabled name tag to it. With pilot, it worked very beautifully, right? People were able to search what they needed with their product. But when it went to production, what happened is folks were trying to prompt engineer the search bar. So the expectation is different. When they see Gen AI, people have all of different sort of expectation of what Gen AI can deliver to them, right? So those are the constraints under which agentic AI systems are there, right? And then the cost, latency, and safety and evaluation, these are the bigger challenges that are needed to be solved there. Evaluation is an active research space. These are stochastic processes. We don't know how to evaluate it. We are all used to having a deterministic accuracy number at the end of it, right? So these are different systems. But given all of that, right, how to get started or how to get kickstart with one of that POC that could help you cover the first mile and could deliver value to your business. So start targeted and modular. Take any existing process, break it down piece by piece, figure out friction processes that are existing between the system, right? To those, let's say, I'll start with an example, right? Let's say you have an NLP model where the input is text data and the output is labels that are coming out of it. Think, could the input data be reformed with LLM? Could you pre-process it so that the NLP model can make a better prediction? Could the predicted labels, could they be enhanced or augmented in some sort of manner for the user? Now that starts your LLM workflow, right? When you think of it, you combine this LLM workflow, you add a planner agent to it, you add orchestrator, you add validator, that gives you a task-specific agent. When you combine multiple of these task-specific agents, that's when you get your agentic AI, right? So in terms of thinking from an existing production system perspective, think in terms of block. You start adding block by block. What those blocks will also enable you is think in terms of evaluation when you're adding a block, right? It's hard to think after designing a system of how will I bring in safety? How will I bring in evaluation? All of those things, right? So go from an LLM workflow standpoint to an agentic standpoint. Think about augmenting first and automating later. When we think of agentic AI, we quickly think that, okay, this is where we can just replace a human. We are not at that stage with agentic systems, right? What we need is, we need to augment it first, make it easier for a human to use. Once the trust and users perspective builds in, that's when we can start automating it. Iterate fast, but keep safety in mind, right? Also, choose a hybrid model strategy. One model is not going to work for all of those things, right? Choosing a big reasoning model at all places, even for smaller validation, doesn't work. These are the constraint and enterprise environment. We have limited set of models available out there, right? With open source, when we are experimenting at our own pace, that's good. We can pull in any model from Hugging Face and play in. That works. But with enterprises, that's not the case. They're very restrictive in what models are available, how you can scale them, how you can use them. Think from a hybrid model strategy. These are the things you need to. This cannot be retrofitted, right? So these need to be planned ahead when you start with your POCs. Again, the last point, score by impact, not by shine, right? Make sure that those agentic are actually adding business values at this point. And all of the points that I'm covering here, these won't help you build the best agent, but will help you build the most reliable, human-friendly, more of user-friendly, and help you get a business buy-in, right? Once you get that business buy-in, that gives you a momentum to get actual agents to production. So you got started with POC, right? Now what next? How to go to production and what to keep in mind. So when taking any agentic POC to production, right? Think about memory. Memory will play a big role with this agentic systems, right? If you have a lot of agents working throughout your system, you'll need to start off thinking memory as a service layer. It needs to be short, long, episodic, all of those kind of memories, because each agent will be needing its own requirement. Think from a workflow design perspective, right? As I said, it's stochastic processes. So we need to put in strategic deterministic things in place. It could be a validity check. It could be an LLM. It could be a machine learning model in place, right? All of those things. Think from a term of model fit and mix, right? It doesn't make sense to overkill agentic solutions, right? Although adding a reasoning model won't solve it. If agents are if it's not able to do it, it could be replaced with something else for now. And when the models graduate, we can take it to the next level, right? From scaling and enhancement perspective, think of context engineering. Now, this is a bigger challenge. When we work in POCs, we think of, let's say, I'll take an example of few-shot learning. With few-shot, you might have 10 examples in your POC for an agent to perform, right? But in production, that 10 examples, running it every time will cause latency, will cause more compute. That compute could be used for reasoning or some other purpose, right? So think of context engineering. Could those examples be shortened by run specific, narrowing it down to what's useful, what's not, right? So think from a context engineering standpoint, think of agent ops. Agent ops is a totally new thing that we need to consider. Classical MLOps was one, but now using E2A standard, MCP standards, all of those things, how your agent is communicating outside, inside, all of those things. Tracking telemetry of the model is again a new thing that's coming out. We need to monitor each tool call, each thing, each step that was executed. It's becoming more and more important to debug the systems, right? Think from knowledge boosters. So all of these LLMs by itself are good at answer generation, right? When we make it agentic, we make them good at decision making. But if you want to make that decision in terms or context of your domain or your enterprise solution, that's when added with search and adding a knowledge graph to it gives it a context awareness, right? So think of it as a human brain. How will you think? We have everything mapped out. Till the agents have things mapped out, making them grounded to your enterprise solution is difficult. So this is, like, let's say we talked about how to get a POC running. We talked about what to consider for production. Now, how to make sure that your teams are evolving from POC to POC, right? Because let's say you built an agent today, would be outdated 6 months from now. Will be new LLMs coming out, more capability, more rigor. All of your agent could be just solved by one LLM if we think that way, right? We don't know, and we need to build that strength or resilience in our teams that we keep on evolving from POCs to POCs. Think of internal benchmarking, right? So whenever we develop a POC, make sure that you have your own data set specific, prompt specific, LLM specific, what is the performance. Now, where this will help is in terms of productionization, somebody might need to come in and debug that prompt later. Currently, we debug the code same way, right? And you might not be there. So who makes sure that why this prompt was written a certain way? Because it's all feelings out there. So we need to make sure that there is a structured process of tracking it. What benchmarks was it evaluated on? These necessarily not be external, but your industry domain specific benchmarks, right? Design for reusability, make sure that even though one of the POC that you do fails, there are plugin modules that could be reused to other POCs, right? Like, for example, you might have had a search capability built in. That search could be expanded to other POCs. Think of those manner. If you developed a validator agent, can I pick it and put it in some other agent? Because everybody will be building agents, planner, validator, orchestrator. These are some components that will jump in from agents to agent, right? Think of it from modular perspective. Having a human-centered design, right? Again, we are automating things for humans, not replacing humans. So we need to think from that manner, right? It's more of a co-pilot that agentic systems will bundle. At the same time, thinking the UX, UI from agentic perspective is also needed, right? It's not the traditional clickable UI that we all had. It's more interactive. How do you enhance that UI so it builds trust, right? Let's say an agent is reasoning and going to a step. How do you make sure that those reasoning steps are communicated to the human? So there's a trust built in, so they know, okay, agent thought this, and hence it's went there, right? That's more of, if I would have done it, why would I have done it, right? More of those kind of things. So with that, this is a Dell's example, right? That's where all of the learnings that you're seeing are coming from, like Dell's Next Best Action. It's a recommendation engine for troubleshooting that we have in-house for our internal agents, right? It helps to get customer support faster. It recommends them what should be the next action given a customer reaching out, right? It's the same process we had. If you see, we had a ML a model and baseline. We had a matrix tied to it. We identified frictional gaps, rapid experimentation, right? That gave us learning and feel of the system of what LLMs are, what tool calling is, how many tool calls do we need, what is the complexity of tool call we can attempt, right? All of those learnings. Once we had those learnings, we combined those and decided on the experiments that we can go forward, which align strategically with the business, right? It may not be fancy. If a simple summarization solves it, why do you need to build a rack for it, right? So those kind of things. And again, when this POCs graduate to production, we thought of it from both enhancement as well as augmentation perspective, right? Enhancement meaning it could be plugged into the system, but augmentation is, could it be assisting the system further? Could it take to a new journey or new use case for the user, right? With that, we were able to achieve this seamless integration into production. The system is being used by 10,000 plus agents throughout the globe, leading to at least 10% reduction in time for solving each case, as well as reducing repeat dispatches and making the flow more easier. So that covers my talk. Thank you.
Yeah, for the next talk, we'll welcome Michelle Tabat from Salesforce.
Nope. Okay, well, I'm doing it without my notes. All right. Hi, everybody. So wonderful to be presenting today to all of you. My name is Michelle Tabat, and I am a principal researcher at Salesforce. My research focus area is on the business value of applying agentic technology into organizations. So this talk is specifically, I'm really glad that I went after Anutosh because I felt like he really set up a lot of the context about how some of the challenges and some of the strategies, and I'm going to narrow in really specifically on one of the challenges that I hear a lot from customers and business leaders, which is around how do I actually measure and demonstrate the ROI of these agents. So lots of people I speak to, very excited and enthusiastic about the promise of making our teams more efficient, making our organizations more productive, but actually how do we measure and evaluate that? That's the sort of frontier area that I'm researching at the moment. Okay, so a lot of the ROI calculations and reports that I've seen have been very simple. They can be like, this task takes 10 minutes, and now we have an agent that can do it. And so we save 10 minutes, and that's the sort of time savings calculation. And that sounds, it sounds pretty good on paper, but in reality, you can sort of badly overestimate value if you're not thinking about the real effort that takes people to do this work and the context of the business in which the agent is working as well. So my research focused specifically on starting with this premise, which is demonstrating time savings starts with understanding the work that humans or people do today, and then how agents actually reduce that effort. So why I think this is really important is I believe it leads us to more credible ROI calculations. So rather than thinking about the idealized or hypothetical time savings that agents can deliver when they're working perfectly and every workflow is perfect, really grounding it in human effort data is where we can see much more realistic time savings calculations. So let me tell you a little bit about the research that I conducted. So to assess time savings, what we actually did was an internal survey of 2,700 of our sellers at Salesforce about the time that they spend on sales tasks today. So how frequently they conduct these tasks, how long it takes to perform these tasks, and how complex these tasks are without agents. And then from there, we were able to use that human effort data to help us build out a sort of more general and scalable framework and calculation model to determine those agent-driven time savings and ROI. So I'm going to dive right into the framework about that now. So this framework takes really sort of two core components. The first is task complexity. So when we want to assess time savings, we first want to understand how difficult is it to complete this task for, in our case, a seller or a user. How many steps does it take? What's the amount of synthesis that's required? What kind of judgment is needed? Is it a risky task? And typically this sort of task complexity will stay static over time. And then on the other hand, you have agent maturity. How reliable is your agent performing? What's the type of output quality? Or if you're looking to develop an agent for a task, really thinking about what are the depths of integrations that I need? What are the relevant systems and tools? How clean is our data? All of these things. And what I think is really important about this element is that this can change over time. So as Anushtoj mentioned before, like a lot of things that we are working on today are MVPs, pilots, betas. So of course we know that they're not at perfect maturity level yet, but we want to be able to credibly evaluate the time savings that we have today rather than like the ideal performance. We also want to be able to look at the ideal performance so we can sort of forecast into the future as well. And also identify any of the gaps, like what would have to be true for us to improve that agent maturity to meet that ideal performance state. Okay, so this is where the model kind of comes in. So we talked about the framework of complexity and maturity, and then to actually calculate those time savings, we bring in the third element of frequency or task frequency. And this helps us really determine how much time agents can realistically save. So I'm going to dig a little bit into this framework you can see here. So in the top left-hand corner, you have very, very high complexity tasks. And in the bottom, you have very sort of low maturity or immature agents. And I think we might have all had the experience of trying to use a Gen AI tool or an agent to conduct a task that's pretty complicated. You might have to re-prompt a lot. You have to give different types of information. And then ultimately, you kind of didn't get to the output that you wanted. And so you had to go back and manually do that yourself. So that's kind of frustrating as an individual user, but as an organization, if you were scaling this across your employees, that is an enormous productivity loss. And so that's the type of thing that we suggest to avoid is if you have a really high complexity task, like, you have to be really conscious of the type of agent that you're going to bring into that scenario. On the other side, we have the very low complexity tasks, very low maturity. So here you might, low complexity tasks, say something that takes you 5 minutes or so to complete. If you have an immature agent, it might still have some value, it might save you a minute or so, but when you really scale that, like, are you actually providing significant productivity savings to your team? Like, not so much. Whereas if you have a low maturity task with low complexity task, with higher agent maturity, if you have something that can scale across your organization, for example, drafting an email, that's something that not only our sales folks do, but everybody in our organization does. That's where you can see that really scalable ROI for some of those lower complexity, less time-intensive tasks. But the real bang for your buck is up in the corner there with that higher complexity, higher maturity alignment. You want a task that, for time savings, it's a little bit effortful, takes a little bit of time to do, but you don't want it to be so highly complex that it needs a lot of human judgment, requires a lot of oversight, right? So say we took a task, under each of these quadrants, we have some time savings percentages. So for example, a sort of medium to high complexity task might save you 60 to 70% of the time where you apply an agent to it. That's because it's medium to high complexity. You're still going to need some level of human judgment, expertise, review, etc. So you won't save that full 100%. But if it's an hour task, you're saving 67%, it's like 30 to 40 minutes. And this is where the calculation model piece comes in. Like, how frequently are you actually doing that task? Might seem like a great use case, but if you only do it once a quarter, you're really not saving that much time for your employees. So you really want to be able to identify those frequent tasks, because if you're doing a task that takes you an hour and you're saving 40 minutes and you have to do that task every day, now that is significant productivity savings. Okay, so you might be wondering, do I need to go out and do a 2,700 person survey to actually determine where the use cases that I'm looking at fit? Lucky for you, no, I did that work so you don't have to. What I would encourage you to do is when you have a new use case that you're trying to evaluate for agent ROI, is go and talk to 3 to 5 high performers of people who actually do that task today and ask them these questions in the task complexity and frequency bucket. Maybe a little hard to see, but I'm happy to share this afterwards. Ask them the number, how mature is the agent that you have to actually address those tasks today, like learning from somebody who actually does that rather than from building it just from a system lens. The last thing here is, you want to estimate for, can I actually, if it's an immature agent, pilot, POC, how quickly can I make that agent more mature? And if you can't do that in 1 to 2 quarters, that's something you should really consider as a business about whether it's the right time to invest into that agent, right? Okay, so you might be saying, though, I want a little bit of the shortcut. Can you just tell me which types of use cases I should apply for my business, or I should apply the agents to organizations I'm pitching my agents to? So I will give you that shortcut. What we found was that where we found that agents save the most time is on those frequent mid-complexity tasks with mature agents, or sort of low complexity tasks that happen very frequently, so multiple times a week or more. That's where you see that real cumulative time savings, and you can actually demonstrate that at scale. Low frequency tasks, limited potential. They don't happen that often. You're not going to save that much time. And low complexity tasks, they don't always, you might think like super easy for us to build, but it doesn't always add up to significant time savings that people can really use to be productive. So the last thing I want to touch on in terms of ROI is actually about adoption. So we've talked about all the things in terms of how you can forecast it and how you can evaluate agent use cases, but one thing that we had in our study was we actually asked our sellers, like, what does good look like to you when you're using agents? They said things around accuracy, style, and actionability, all the things that are up here. And ultimately, if we design something that's maybe technically fantastic, but it doesn't meet what good looks like for our users, no one's going to use it, and there won't be any ROI. So that's one thing I really encourage you to think about when designing agents, is thinking about that human-person interaction. All right. Thank you so much for your time. This is how you can apply this framework to evaluate and prioritize use cases for your business, to forecast your agent time savings, and to measure time savings alongside other business value metrics to show the full value. If you have any other questions, I would love to chat afterwards. Really appreciate getting to chat with you all today.
Thank you, Michelle. Our next speaker will be Diva Taka, who is a senior program manager from Google.
Right. Hey, everyone. Thanks for being here. I'm going to talk about this one specific work that we've done. And through the end of it all, I just want to convince you that there's a lot of value in exploring what new interaction patterns are emerging as we kind of deploy these agents. I feel like the last talk was an excellent example of thinking about those real-life human-AI collaboration frameworks. And if there's anything that you need to take with this, is that you need to get a much better, deeper sense of how multi-agent frameworks are coming together as they're deployed in really messy organizational structures. These agents don't operate in isolation at all. This work was the best paper at Kai. This is with collaborators at Stanford and Google. And you've been hearing a lot of hype around software changing in itself, right? Like, we'd love to think about ways in which AI will replace software engineers, and you've got like this whole stack of tools which are coming in to think about like how much code these models are now writing for us. Great. But there's software in itself is a very messy way of working together, where PMs, developers, and designers kind of like come together to actually prototype, think about what to build in itself. And there's going to be a lot of judgment that gets exercised over here. This is a messy process that's not just a value function of like how much code you can write, but how you choose problems and how these teams come together in their own respective organizational incentive structures. So we felt this is an important enough question for us to study, which is how do teams now prototype software in this new paradigm of LLMs, where a lot of the code is being written for them and the process could theoretically be accelerated. So how do you think about like this new design framework in itself? So as at CI researchers, we love to take like one narrow domain and kind of like prove it out broadly in those spaces. So we kind of like got together multi-stakeholder teams comprising of PMs, UX, and developers together, mostly ML researchers, to tell them that they're designing like this new marketing content creator agent for their clients, which is going to write like a whole bunch of marketing content for them. And they're creating like this generative AI tool, which is run through Google AI Studio and uses Gemini at the backend. Awesome. So we have this idea of like how current roles look like, and that is exactly the prescription that we give them, that engineers should be thinking about like what kind of like a few short examples to design. How can you like think of metrics and find the right data and so on and so forth. So we gave them like the exact tools that they would be leaning onto as in their current roles, and we wanted to see how these roles are now shifting. And they had like a bunch of guides to kind of like think through product design in these new spaces in itself, which I won't go too deep into. A sneak peek into our findings. One, there's like this really large focus on content in itself. So there's this wrangling that's happening now, which is around the model outputs being reverse engineered for what kind of prompts you should be writing, what kind of agent instructions that you should be developing, what kind of like golden examples that you should be developing in itself. So it's really interesting how like the prototyping paradigm in itself is being reliant on the LLMs that we've built at the get-go, which in itself comes with a lot of priors and biases on like relying just purely on current model design in itself. So thinking more about like how these golden examples have been curated is extremely critical, and this is happening purely through the modality of content. Evals are extremely hard, as we all know, but this shows up even more so when people try to exercise their own domain expertise onto designing these prototypes. So you'd expect that a PM would look at evals in a very monolithic way, and a designer would care about very specific functions. That's completely changing. And there's a few key ways in which we like to think about like these silos kind of breaking down. So in an earlier world on the leftmost side of it, you see that expertise was kind of like really guided, that as a designer, you're taking very specific decisions, but that's completely changing because now all of the people in these collaborative teams have a shared surface through prompts and content to be able to wrangle these prototypes in ways that they just couldn't. There's this like big focus on like simulating things being really hard, and that's changing because now you're seeing like engineers in itself simulate how their users might kind of like come through with these LLMs to understand like what these journeys are like. So the workflows in itself for engineers are changing, and the expertise that they have is kind of like getting augmented in ways that you wouldn't have expected. Earlier in a predictive AI world, which we all don't even remember about now, there was a lot of like uncertainty around AI outputs, which is now changing because you're able to wrangle things a lot more through the prompt space. But with it comes kind of like its own challenges, because then you're getting like really limited and siloed with what kind of like prompting that you're doing. Technical decisions, again, like completely changed because now engineers don't get to decide what kind of data sets you're using. Those decisions are kind of like getting more and more decentralized in itself. And the same thing is happening with like user-centered decisions, and prototypes are changing from these like really low fidelity kind of like mocks towards actually going towards things which are usable and functional, because you have like these tools at your disposal in itself. So content is the hero of it all. Collaboration is the hero of it all. So if you're designing agents, care about how these agents work in a very, very messy organizational structure where humans and humans come together with multiple agents to kind of like work through the design process in itself. If you want to reach me and talk more, that's my email ID. Thank you so much.
So thank you again, all the speakers, for the amazing talks. So next, we will have Jocelyn from Berkeley Responsible Decentralized Intelligence Center on stage to announce the winners for the Agent X hackathon and the LLM Agent MOOC hackathon. Yeah.
If all the winners, once I announced you, please line up on the left-hand side and you'll have a chance to speak. And we will help you line up. But first off, I'm going to talk for a few minutes just about the competition before I announce the winners. So thank you to everyone who participated in the competition. I'm Jocelyn. I'm a deputy director at the Berkeley Center for Responsible Decentralized Intelligence. This was our second agents competition that we ran. We ran one in the fall. This was the follow-on to that as part of the Advanced LLM Agents MOOC. And as you can see, we had almost 1,000 teams participating, 500 startups joining, and over 100 countries represented. So we had $450,000 in prizes and resources from our sponsors. You'll be hearing from a few of our sponsors also after I announce the winners. But thank you to everyone who participated in that. So the winners for the entrepreneurship track, I'm very pleased to announce. First place, Raycaster. So congratulations to you. And maybe I'll ask you to hold your applause until I announce the fourth place too. Second place, TradeStack. Third place, WeCruit. Fourth place, Minimist. Cheers. There was a special prize track from Auth0 for people utilizing Auth0 solutions in their project. And I'll announce all the winners, and then we can applaud. First place, TradeStack. Second place, Chris Pro. And third place, Anub AI. So congratulations to all of them. We also had quite a few winners in the research track. That was very well represented. First place for reasoning and planning, Nova Sky, and second place, Agent V Bench. Congratulations. And for AI safety and alignment, which was sponsored by Schmidt Sciences, we had 4 tied for second place, but the first place was Team Hoosier. Tied for second place was CVE Bench, MedPair, COP, and Ken Hwang, Vineeth, Narajala, Aiden Habler, and Akram Sharif. So congratulations to all of those for AI safety and alignment. For the rest of the research track winners for benchmark and evaluation, we had 3. The first place was Agentic benchmark checklist. Second place was a tie between Agent Synth and online learning to prompt leaderboard. Congratulations. Agent architecture, first place GNX, second place AIOS. Congratulations to them on architecture. For multi-agent, first place EvoGit, second place Social Agent, and third place efficient training-free online routing for high-volume multi-LLM sending. Congratulations to all of those research winners. And these were all of the sponsors who contributed prizes and resources. And what we'd like to do is welcome a couple of our sponsors up here. If you are one of the startups or that we announced as a winner, please line up against this wall over here, and we'll have you present for a few minutes if you're here. I'd also like to welcome up from Lambda, Ryder, and Auth0, their leaders, to say a few words.
Hi there, everybody, and congratulations to the winner. I am Bhavna Singh. I'm from Auth0, CTO there, and which is acquired by Okta. Can everybody hear me? All right. Well, congratulations to the 3 winners we called out for using our platform. More so, I would say, this is a great gathering, some great ideas, but what I love about these ideas is that you're using the technology, which is, of course, evolving very fast, to implement and bring true use case that will help the humankind, I would say, in different ways. Efficiency, optimization, but most importantly, bringing the price or the cost down. So thank you for all the hard work you're doing. I will also call out that our platform certainly helps with key capabilities for you to build tooling, for you to build agent-to-agent conversations to make it very easy, but also to help you build MCP capabilities. So whoever used it, thank you so much for leveraging all those capabilities. Hopefully it was easier, and we would love to take some feedback from you as to how it was and your experience in leveraging these capabilities, because we are also evolving them. Thank you so much, and congratulations, everybody.
Yeah. And Dennis from Ryder.
Hi, y'all. Thank you. Congrats to all the winners. Super excited to dig into the demos and check out the awesome stuff y'all did. My name is Dennis. I'm a member of technical staff at Ryder. We're hiring. Come check us out. We have our proprietary Palmyra LLMs. We're doing all kinds of cool stuff, especially with Agentic AI at Ryder. We're up in the CARE lobby. We have 100 open roles, so please come check us out. We want to hear from you. We want you to ask us questions. And that's it. Congrats again to all the winners.
Thank you. And Juana? Oh. Oh, from Lambda. Yeah.
Hi, everybody. My name is Leah Alcantara from Lambda. Congratulations, first of all, to all of the winners. Incredibly excited for all of you. I'm a machine learning engineer here at Lambda, and just want to also kind of mention that we are, you don't know us, we're a GPU compute provider, and we have a ton of open roles. I can't speak more highly of this company and all of the amazing things that we're doing right now. So feel free to come check us out. We have a booth on the 3rd floor, and also we're actually currently speaking in a presentation on Agentic AI and Neural OS upstairs on the 5th floor. So please come talk to us, and congratulations again, everybody.
What I have here now is the list of startups and the order that they're going to speak. So I don't know, have they all lined up in this order?
I don't know.
Yeah.
I don't.
Okay. First up is Team Hoosiers. And then second will be Agent Synth. Third will be ABC. Fourth will be a noob. And then Agent. So if you could all line up in this order, hoping you can see that. All right, I'd like to welcome up the first team, Agent Synth. Team Hoosiers. Yeah.
Hi everyone. We are Team Hoosiers. My name is Jen, and this project is done with Zichuan Li. So in this project, we're trying to propose a privacy-enhanced development paradigm for multi-agent collaboration systems. So given a multi-agent collaboration system, there are multiple communication channels, including the inter-agents and the agent to other environments, such as tools, LLMs, and the users. However, any of these kind of components, entities could be malicious. For example, agent could be malicious, or because of third-party tools and because of the third-party LLMs, this can also be malicious. So in these projects, we also see that the sensitive information disclosure is also already being recognized as one of the OWASP top 10 vulnerabilities for LLM integrated applications. So in these projects, our research question is that how can privacy enhancing techniques can be effectively integrated into multi-agent collaboration systems while ensuring like seamless deployment. So we have like 3 design goals. So our paradigm is called the MARIS, which is a multi-agent data safeguard development paradigm. So we have 3 goals. The first one is configurable and customizable data protection policy, which means that we want to have a single configuration files that can enforce these kind of policies. And the second one is that flexible monitoring across all communication patterns. So as I mentioned, we have like a different communication channels. We want to protect all the protections on top of this one. And the third one is the seamless deployment. We don't want to change a lot of code in the applications, but we still can deploy this kind of safeguard. So overall, we implement our design goals into major platforms, LangChain and AutoGens. And yeah, to summarize that, we propose a privacy-enhanced development paradigm for the multi-agent collaboration system. While it is specifically designed for the sensitive disclosure attack, but can also be extended to other detection purposes. And we also have some like a privacy assessment framework for evaluating the MACS under like different privacy threat scenarios. Thank you for listening.
Yeah, hi everyone. We are Agent Sense team, and I'm Jingshu. I'm going to talk about our project on scalable task generation for general computer use agent. As we all know that our agents are currently much more powerful in solving complex and multi-step computer use tasks like booking flights, booking hotels, or some other tasks. But data collection for this realistic training and evaluation is very scarce, and it's hard to scale. So existing benchmarks mostly rely heavily on like human demonstration, which is pretty expensive and hard to scale. So our project, Agent Sense, offers a scalable and low-cost pipeline to synthesize these high-quality tasks, which achieves only $0.6 per trajectory. And the key idea behind this achievement is using information asymmetry. That is, to generate simple subtasks and chain them into a complex one. And from that, we enable control task complexity. So our pipeline started with a random persona, which enables a wide diversity of the tasks. And from the persona, we propose initial task and then iteratively generating follow-up tasks to change them into to compose them into a final and complex task. By chaining different numbers of subtasks, we can control the task difficulties in a controlled way. So for example, we chain 2 subtasks, we get some low difficulty. If we chain many subtasks, we can get a very high difficulty. Based on that, we create a benchmark and we evaluate several sorter models like OS4 Mini, Gemini 2.5 Pro, etc. And it seems that with increasing the difficulty, even the sorter models are struggling with our benchmark. And with that, I want to conclude that I hope agencies can push forward the development of the agent training and evaluation. Thank you.
All right, hi everyone, I'm Yuxuan, and I'm excited to introduce our research around AI agent benchmarks. So as we can see from recent analysis, AI agents have become increasingly and surprisingly capable. However, we are still not sure what agent can do and what agent cannot do, and that's exactly why we need AI agent benchmarks. So a typical AI agent benchmarks have a real-world task where an agent needs to interact with the environment, which typically contains a few simulators of the real-world scenarios. And then we'll have a grader to look into the agent's output and decide if it's a success or failure. So we have 2 challenges. One is a complex setup. We need to set up DB, websites, and container. We also need to deal with non-calculated data, including free-form text, code, and function calls. This kind of complexity raises a huge surface of unreliability, and what if there are bugs? To address it, we introduce our Agentic benchmark checklist. We want to help benchmark builders and users to detect validity issues in an agent environment paradigm and various evaluation designs. We also propose guidelines to help rigorous reporting when validity cannot be achieved. We identify many issues that can skew benchmarks and results and findings. These issues can cause up to 100% misestimation of agent performance. So feel free to check out our work. Our post is on the 2nd floor of the building. And let us know if you have any comments or questions. Thank you.
Good afternoon. My name is Alex Garcia, and I am the CEO and co-founder of Anube.ai. We're all here because we're excited about the promise of autonomous agents. But as we deploy those agents, and having deployed the agents firsthand for the enterprise, I come across one very critical question, is how do we actually measure success? It's easy to mistake success for agent activity, but in actuality, activity does not measure or drive results. And that's why we came up with the key agent outcome, which is a time box metric for defining success for the agent. Each agent outcome is validated by a human-in-the-loop checkpoint, and this validation process ensures accountability that every agent's contribution. This isn't just about automation, this is automation with accountability. And with this methodology, it aligns how customers are charged for the value that agents are achieving for them. Thank you.
So next one is scheduled to be the team of Agent God.
Good afternoon. My name is Zhizhou Chen, and our project is repurposing Agentic orchestrator for safety evaluation of tool orchestration. So basically, the introduction of autonomous tool use have turned LLMs into powerful agents. However, when those tools are misused, these agents are practically turning into potent adversarial entities. So that is that, it might be good to have a pre-deployment testing framework so that we can yield potentially unsafe tool workflows as many as possible and address them ahead of time. So we argue that this testing framework must satisfy 3 requirements. The first one is that the framework must have the knowledge about the capabilities and how to use the tools. And the second one is this testing process have to be realistic and scalable. And the third one is that this testing framework must have the privilege to invoke the tools so that it can validate these identified unsafe workflows. So our observation is that actually the LLM orchestrator within the LLM agent system innately satisfy all the requirements. So in this project, basically we turned LLM orchestrator into safety evaluator, and then we did a baby version of proof of concept. And for more details, please read our project report. Thank you.
Yeah, hello everyone. My name is Herman. It's a huge privilege to be here. So our project started with simple observation. So almost, I can think of more than 30 years of history of a public web, the input forms remain the same. So you can see it on my screen. Why is even problem? Because actually the role of these input forms dramatically change. So for example, finance companies now spending like 55 USD per click in search, and 75 forms are actually abandoned while users started them. So that's why we in the cross-disciplinary disciplinary team created the voice agent that actually can guide you through the forms. They contact you from the phone. And I think the main idea was to experiment with tool calling. So this agent actually have set of tools that can, in real time, fill out form for you, change the things inside this form, and that's all. So yeah, I think my time is up, and yeah, you can drop me a message if you're interested in this.
One here very interested in healthcare. Awesome, only one. That's very important to talk about our project MapPair. So MapPair stands for Measuring Physicians and Artificial Intelligence Relevance Alignment in Medical Question Answering. I know lots of recruiters and great companies are here, so hire me. I'm on the job market, final year PhD student. So the project starts from a very interesting idea. Like people ask about, so how physicians are interpreting this patient profile, how does large language models are things in this input profile. Are they really alike? It's pretty dangerous if they're not alike, so that's why we're asking this question. So in a study, we formed a MapPair data set, which formed 2 data sets into a patient profile and a query. And then we invited 36 physician annotators and 4 large language models to first do the classification and then do the relevance labeling per sentence level. So our results are very interesting. As you can see, if large language model follows the human relevance labeling in the sentence level, in the 4 data sets that we form, it improves the performance. As well, we also tried large language model use its own high relevance sentences to do this improvement, and we can also see the same relevant trend. So that's all for our project. Thank you so much, and look at our project. Thanks.
Good afternoon. I'm Chinong from GNAI's team. I'll be presenting our work on agent-based autonomous manufacturing. The core problem we are tackling is that traditional manufacturing is too rigid for today's dynamic market demands. Our solution is an AI-driven system where workers can control complex machinery using simple natural language. We use an AI agent that leverages standard digital twins called asset administration shell to understand the factory's capabilities and a model context protocol to execute our commands. We validate these 2 ways. First, we conducted a large-scale experiment with 4,500 industrial data files, showing that the top LLMs can automatically generate the control code up to 96% of success. Second, we demonstrate a complete end-to-end process where our agent is successfully manufacturing an AFP motor cores. Thank you.
There should be a link. This one. Click the online side.
This one here?
Yeah, this one here. F11. Do I need?
So hello everyone, here I'm introducing the EvoGit. I'm here, I'm Beicheng Huang. First, let me get through what's the pain points in today's coding agents. As you can see on the right, it's like how a typical coding agent works. There's an agent, you generate code, you run tests, and if the test is good, it's done. If the code is bad, it writes different codes. However, there are some issues here. One is that agents run like in a single-threaded mode. Like typically all the agents model, they run in a single-threaded mode. And second thing is that it's hard for agent and human to collaborate, or the human-agent dynamics, because either is agent do it all, or it's like human-agent frequently interact with each other, saying like human says you are doing it right, you are doing it wrong. And the third thing is that reward function doesn't work. The reward function means here is to how to measure how good the code is. For example, you are saying like the code is 90 score good. That is very hard. You can't just give a single scalar value to how good the code is. And our solution to that is to bring down everything and redesign everything. So the state of the agent is the graph. The code evolves, not actual. And the collaboration is done through the graph itself, not communication. And there are no scalar reward here. Everything is partially ordered. There's no scale. Everything is done here. And we have some nice website here, as you can check out in the poster. And thank you, everyone. So EvoGit, there's a final code that LLM models are known, and evolution is for creating the unknowns. And we are doing that. Thank you.
Is the team of Agent Waybench here? If not, the next speaker will be the team of Youth AI Safety.
So much. Hello, everyone. We're a research team from Illinois, University of Illinois, working on designing safer generative AI experience for use. And my name is Yaman. So large language models are reshaping how users interact online, but the current safety measures often overlook their needs on developmental stage. For example, moderation systems may capture the explicit content, but they often miss what is subtle and serious from the user perspective, such as teenagers receiving validation from AI about their intimate relationships, about their emotional vulnerabilities, even their self-harm or suicidal ideations. To better understand what are the risks behind of their interactions, we developed a use AI risk taxonomy and also created a data set from their raw chat logs with generative AI to reflect on their risky interactions. And also, we trained a safeguard model for use specifically that improves very much of the specific risk of them. And our ultimate goal is making the AI environment safer and more developmental appropriate for use. Check out the details of our website, and we have a poster on the third floor around the main stage. So come to talk to me. Thank you.
Hi, my name is Julius, and I'm here to present to you iWhisper, our interactive visual spatial reasoning benchmark for LLMs. So with the rise of LLMs as agents, there's also been a growing interest in applying this world knowledge to the physical realm with robotics and the like. However, there's a large gap. LLMs have a lot of world knowledge, but it is known that they struggle to apply that knowledge to the physical world. So how do we help this? Well, the first thing, we want to accurately measure their spatial reasoning and visual grounding abilities by building a benchmark. So what we did is we built a Unity sandbox, and we built on top of it an LLM agent API that works in a way that agents can receive observations from our simulator and apply structured text back as actions. Inside the sandbox, we built a 3D puzzle suite by implementing popular puzzles like the sliding tile puzzle, a geometric puzzle, and the Rubik's Cube. This runs on any operating system, browser, and even HPC clusters. We support any state-of-the-art VLM APIs, and we can even do analytics on reasoning across modalities. We have automatic testing and evaluation, and if you're interested in finding more out about our results, you can meet me at the poster session or go to our website, iwhisper.ai. Thank you.
Hi, I'm representing Team TARS, and we built Simera, a general goal-oriented agent via simulative reasoning with world model. So existing work usually develop architecture for specific environments, and this approach usually suffers from issue with scalability in terms of business and error propagation, and does not offer a clear path towards general intelligence. But humans, on the other hand, are generalists with a single cognitive architecture, but can achieve goals in diverse environments. So human reasoning is not just linear autoregressive reasoning, but also forward-looking simulation-based reasoning using internal world model. Based on this, we built a general architecture for optimal goal-oriented agent, and we overcame the limitation of LLM-based autoregressive reasoning by introducing world model for planning via simulation. So for experiments, we improved the performance substantially in web browsing tasks. A quick demo. So this user is asking Simera to plan a trip from Pittsburgh to SML 2025. And then Simera starts to look up info, and then find hotels, search for flight, then research action, compose a response to the user. So feel free to scan the QR code to check our blog post and demo, and we have our poster over there. Thank you.
Okay, hi everyone, I'm Yuxuan. I'm excited to introduce our project CV Bench, a benchmark for evaluating AI agents' capability to exploit real-world web application vulnerabilities. So recently, we are seeing increasing trend where AI agents potentially present major cybersecurity risks. And to measure the real risk, we built a benchmark, CV Bench. We picked 40 high critical severity CVEs from the real-world benchmarks and used open source web applications. We also manually reproduced and verified each task with at least 2 iterations. So in our benchmark, the agent needs to interact with the web application, and we have an application-specific evaluator to evaluate the agent performance. In our experiment, we found that a GPT-4o-based agent can exploit up to 13% of the CVEs. So if you find our work helpful and interesting, feel free to check out our paper. Our poster is on the 2nd floor of the building. Thank you.
Hi, this is Team DAMCS. I'm excited to share with you our vision on future of multi-agent systems. In the future, we imagine that agents are deeply embedded in human society. Each of the agents act decentralized way, and by communicating with others, they form a network with other agents and with other humans. Together, they can collaboratively plan and act. Okay, so here's our DAMCS framework. The DAMCS framework contains 2 components. One is the decentralized adaptive knowledge graph memory. Each of the agents maintains individual knowledge graph memory. By communicating with others, the agents are allowed to share states, share task progressions with other agents, and together they're able to complete tasks cooperatively. On the right is the MA Crafter benchmark. So this is a benchmark designed for evaluating cooperations. This introduces item dependencies and it introduces cooperation dependencies and constraints. So here's DAMCS agents operate in an open world environment. Their goal is to gather a diamond together cooperatively. And there are cooperative actions such as share, allowing agents to share items with each other. They have to reason through communicate in order to complete the task together. Check out our project by scanning the QR code, and happy to talk with you.
So hi everyone, my name is Fang Zhou, and I will be introducing our work, efficient training-free online routing for high-value multi-LLM serving, which is a joint work with NDPCO. So as LLM becomes more widely used, balancing cost and quality becomes critical. LLM routing offers a solution by routing query to the most cost-efficient model But the most existing work primarily focuses on offline scenarios and fell short in online realistic settings. And they struggle with high routing latency, deployment cost, and complex query arrival patterns. So to tackle this, we proposed the first training-free online routing algorithm. So we first estimated the query features, for example, the cost and the quality using approximate near neighbor search algorithms. And then we formulated the routing as an MILP and proposed an efficient routing rule with learnable routing ways. So these ways are learned on just a few initial queries and can effectively guide future query routing. So we back our algorithm with formal theoretical guarantees. Our algorithm achieves a lot in performance, cost efficiency, and high throughput. So feel free to stop by our poster for more details. Thank you.
Hi everyone. Let me start with a question. Have you ever scrubbed through a 10-hour lecture video just to find that one slide you needed buried at hour 7? Or tried to recall what someone said in a keynote, maybe about multimodal search, but couldn't find the clip before your meeting? Yes, we have all been there. Tech events and online lectures are packed with insights, but they are lost inside hours of video. It takes too much time to get to what matters. LearnPod changes that. It's not just search, it's an interactive AI tutor that watches entire events and lectures for you. Powered by a multi-agent LLM architecture, LearnPod understands video content and transforms long recordings into a conversational knowledge base. You can then ask questions and instantly jump to the most relevant segment. AI is going to change videos forever. Videos will become fully interactive and immersive, alive with meaning for every learner. And that's the future we are building with LearnPod. Please come visit us at the poster area to learn more. Thank you.
We live in an AI world. I think we've already established that. But the hype and marketing that currently surrounds it is significantly different from what it truly is. To know something, there are two ways. One, to know what it is, and the other, to know what it isn't. So today, I want to focus on the pitfalls on the over-reliance of AI by understanding its limitations, so that we could be more confident and intentional when we do use it. At a very high level, LLMs are still just autocomplete on steroids. They don't understand meaning. They predict the next token with the highest probability. This works great for several tasks in a wide range of domains. But we need to be cognizant of the fact that linguistic fluency correlates well with logic. So it looks like intelligence, but real intelligence is about abstraction. It's about forming mental models and understanding and conceptualizing ideas. This is why AI is great for scaffolding, but not for skyscrapers. LLMs are great at generating boilerplate and exploratory tasks. But if you're doing anything complex, they fall apart. Let's take an example where language and logic fully decouple. Legal documents. In law, a single wrong word or even a single misplaced word can change the entire meaning of a legal contract. LLMs may generate something that sounds correct but lack the required legal precision. In addition, there are already legal cases where AI-generated legal briefs include fake citations and hallucinated case law. Even the so-called reasoning models that use chain of thought are still orchestrated token emitters with better analysis and tools. Is there really a deeper understanding behind the curtain, or is it just flowcharts pretending to think? So if you're doing anything complex or novel, don't outsource your intellect to LLMs. Use AI for speed, not strategy, for suggestions and not decisions. And always perform your due diligence and keep abstraction and understanding, the hard part, for yourself. I'm not saying any of this because I'm an AI doomer. I use AI every single day, and I build agentic systems. Come check out our project, Smooth Operator. Even for this talk, I used AI to formulate my thoughts, but not to form them. I care deeply about this space, and we need to set reasonable expectations so that AI can grow at a steady and meaningful pace into something transformative, making the world a better place. Let AI augment our intelligence, but not replace it. This is Sainath from Mycognito. Thank you.
Perfect. OK. So hello, everyone. Today, I will be presenting the COP, Agentic Red Teaming for Large Language Model using Composition of Principles. So as we all know, as LLM advances, they still remain vulnerable to existing jailbreaks attacks. However, our current red teaming method has significant limitations. requiring white box access, consuming excessive tokens, or being model specific. So our solution is pretty simple, and we propose an innovative agentic workflow that combines simple human-designed attack principles to generate effective jailbreak strategies while using dramatic fewer queries. So here is the overall pipeline. By taking, so first of all, the input is the harmful query, and then the red teaming agent will, based on the input, and then combine the appropriate attack principles to form a composition of principles, and then to shoot that out as a new jailbreak prompt, and then using this feedback to create, and then we're evaluating the effectiveness using the judge LLMs, and then use this to feedback, increasing the protect attacks. And then here's the illustrative example of how our COP works. And then in terms of performance, as we can see that COP significantly outperforms the existing method, providing developer a more efficient and transparent way to identify vulnerability before model release. And that's my talk. Thank you.
Hello, everyone. My name is Eduardo, and I'll be presenting continuity of mind, grounded memory-driven cognition, and LLM agents. Our research tackles the challenge of enabling structured, memory-driven cognition within large language models. We introduce a meta-agent architecture that repurposes the context window as a dynamic substrate for cognition. At its core, a hidden controller routes control based on the context among specialized agents for perception, belief formation, episodic, and conceptual memory integration, as well as decision-making, creating an explicitly structured external global workspace. This architecture supports both reactive, fast system 1 behaviors and deliberative, structured system 2 reasoning. It significantly improves temporal coherence, interpretability, performance on complex tasks like ALF World, all without gradient-based training. While today's LLMs are capable of intelligent thought in latent space and can generate fluent outputs, they lack persistent internal reasoning. They do not understand their own thought processes before externalizing it. Our immediate contribution is an explicit external framework for coherent memory-integrated reasoning. Our longer-term vision, however, is the emergence of artificial experience, models that internally articulate and reflect on their own intermediate thoughts. We believe this points to a path forward where interpretability and performance are not at odds, but mutually reinforced through structured, persistent cognition. Thank you.
Hello. The story of treating cancer is built on a broken foundation where we wait for cancer to show up and then we treat it. At CRISPR, we built an AI agent where we can analyze all pathways of cancer before cancer has even occurred. How we do this? By applying simple theories like the two-hit hypothesis. We utilize the first mutation, which is the RUNX1 mutation. When someone develops this or inherits this, their likelihood of getting leukemia increases by 50%. Combined with another mutation known as the second-hit hypothesis, now this is when the beginning of cancer phase starts. Our foundation model is able to analyze genes and it's able to predict what's the likelihood of these genes being pathogenic, and we're able to give it a score which determines the accuracy. Once we identify a gene that's likely to be a tumor or could become cancerous, we can then predict the second hit, and we can predict what's the likelihood where the next cell could transfer before it has even transferred. Our foundation model also allows us to build proteins where we can then disrupt and kill these cancer cells using CRISPR therapies. Thank you so much.
Hi everyone, I'm Sarah from TradeStack, and we're a pre-seed AI startup in London. And we're building an agentic back office for contractors like plumbers, electricians, and so on. And I'm just going to share 3 sort of key insights from what we've learned over the past 12 months. Is from a user interface point of view, this target audience really it has no interest in any new interfaces whatsoever. So we have to leverage the existing interfaces, especially WhatsApp, email, and phone. And then from an MCP point of view, it's obviously great building in this era of MCP, but we've learned that building your own toolkits can give you your own control, and especially when it comes to auth, it gives you important control. And then lastly, human in the loop is really important for us. So our business model is services as a software. So we actually build for our own internal teams, which means we have internal feedback loops, and that obviously is quite helpful in delivering a premium sort of service. Thank you.
All right, hi everyone, my name is Noah. Can I see a quick show of hands how many of you used ChatGPT in the past week? Of course, basically we all use it and it's so powerful, but it also leads to a problem. For example, in the recruitment industry, basically everyone is using ChatGPT to help them to refine their resume, so everyone's resume looks so amazing, but what's real, what's not, what's actually from the candidates, we don't know. And there's only way to figure that out, that's by actually talking to them, because you can't fake your first, second response to a question or your problem-solving skills. But the only reason why we are not offering everyone a chance to interview is because it's so expensive. But what if we offer a solution to help you to give everyone a chance to interview and see their performance? That's what we build Recruit. So our solution is that we only need your job description, and then we'll build an interview experience customizable to your candidates based on their background and your JD. And also in the end, we'll give you a report to see how they performed and you could rank them. And while they are talking, we'll also give you an emotion analysis to see if they actually engaged into the position and the interview process. And also we use AI detection heat map to track, are they using AI cheat tools to help them go through the interview process. So clearly it won't pass our interview. And in the past 4 months, we have done 7,000 to 8,000 interviews already, and we have helped 2 incubators and 2 consulting firms and 7 academic institutions to do their screening process. So if you are interested, let's skip screening, start selecting, and contact us. Thank you.
Hello everyone, I'm Tim Husers, and I'm going to present our research across to data harvesting and polluting in multi-tool empowered agents. Let's take an example. A user is asking for some financial investment suggestions to a language model, and this model can invoke these 3 tools. It can invoke Yahoo Finance to fetch news, stock data API to fetch stock price, and data analyze to do the data analysis. And it may have this control flow. We call it, this execution order, we call it control flow of an agent. And to look into the detail of the description, Yahoo Finance description mentioned that useful for when you need to find financial news about a public company, input should be a company ticker. However, as we see that user input doesn't provide such knowledge, it's only mentioned that Apple is not the company ticker AAPL. So here is a knowledge gap. And if a malicious tool claims to provide such knowledge, it can hijack the control flow and sneak into the right in front of this Yahoo Finance. In this project, we study this threat, and we call it cross-tool data harvesting and polluting. Once hijack successful, the malicious tool can perform the data harvesting attack to steal privacy information, or the polluting attack to pollute the agent context. And we built a threat scanner to investigate how prevalent this threat is. And we found that a lot of open source tools in LangChain and Llama Index are vulnerable to this threat. And thank you. If you are interested, please feel free to find me in the post session.
Thank all the speakers for the very interesting 19 talks. So now we will dive into the second session of the afternoon, which is about the foundations of agents. By the way, I'm Jing Xue. I'm a postdoc working with Professor Dong Sang. So I will be the session chair for the previous session, this session, and the next session. So if you have questions, please come to me. So our first speaker for this session is Jose Reynal, who is a professor at UC Santa Cruz.
Welcome. So what I'm going to be talking today is a work that we are doing in Santa Cruz, and it's how to build agents for chip design, hardware agents. A little background to see what we are doing here. I'm a professor at UC Santa Cruz. My background is computer architecture, so chip design. But I always have been doing how to improve the productivity. Obviously, that includes design, verification, different aspects of the chip design. But today the focus is AI agents, how to build agents to help me improve productivity at this globe. Now, obviously, this is a work for a lot of my students, myself, that's my Git commit history. I like to work too on the code. So what's the goal? Because I think it's important we set the goal, what I'm working about. So the idea is to improve chip design productivity. And this includes the coding, the verification, a lot of effort on optimization parts. And there can be some cloud, either CLI kind of interface, and this is something we are working on. It's not how to integrate AI on the EDA tools. There's a lot of people working on that area. It's a different community. Here is how to improve the productivity, much more like what we are talking here at the conference. Because it helps you to understand how do I approach the problem and what do we do. I think it's important to what is my view on LLMs? How do I see them? How do I use them? In a way, they are sort of an alien intelligence. So they are better than humans in some things. So they are better as excellent translators. So they can translate to English, French, much better than me. They have excellent recall, or not excellent, but very good recall, much better than humans. But in some way, they are worse than humans in consistency. They have maybe not very good term, but funny failures. They have many strange failures that you have. So how I'm gonna make it work with this? Well, the first thing is I'm not going only the LLMs, I'm building on agents around. So the agents, I tend to call it many times grounded agents. I tend to call it more verifiable agents whenever I can. The idea is that we always have coupled the LLMs, whatever we use, with checks, and whenever possible, we verify. In hardware, we can verify many times the results. So what we keep doing is building pipelines in which you can have an output of the LLM, and then you check if the result is correct. If not, you keep adding back and you keep iterating. Because we have these verifiable agents that we can build, so we can iterate and go towards a better solution. So we check with the EDA tools whenever possible, like do we have mistakes, like combinational loops? Do we have things that they shouldn't be happening there? And if we have a verification infrastructure that usually in hardware you tend to have it because it's very expensive to do a mistake. So then you can check with the verification infrastructure. Whenever possible, you validate with previous results. Many times you are doing optimization, you are just transforming the code to get better quality code. So in that case, we can use formal tools to formally prove that the code is equivalent, even though they look very different. So at the end of the day, there are many blocks, and it looks like a compiler. So you have blocks that have the typical React loop, so you can have some reasoning to expand. You might want to extract the inputs and outputs. So, and you have a compiler-like flow. So what makes hardware special is that it doesn't work with a normal, Python is a von Neumann architecture. Hardware is not when you program hardware. And there are many issues. Not von Neumann, pipelining is a very specific way of parallelization that the LLMs don't have very good training and they do a lot of mistakes. And there are a long list of the slightly different on the programming language. But for the non-hardware people, I have a little slide. So if you were having a program like this, you say the result of C is the result of multiplication A and B, and then you write assert that C is the result of the multiplication, and let's assume that this does multiplication. In hardware, this can fail. And the reason is because the result might not be this cycle, might take 2 or 3 cycles later. So there are a lot of checks that you might have to do that the code generation on the LLMs don't have that assumption because there is not enough training set for these type of languages. So how do we do? Because it's a short talk, I'm just going to show you a high-level view what is the idea. So we have 2 programming languages. One is Verilog, the other one is Chisel. So how do you do a reverse pass? So you can build a compiler-like infrastructure, putting the LLMs in the middle to solve this, and at the end there is no hallucinations because you formally prove that the result is correct. So what do you have? You have original Verilog, you have a fixed Verilog, so you have a change, and the original Chisel. You want to have a patch on that Chisel. Now, the first thing, you have to narrow the space because those files are gigantic. So you do a diff, like a fuzzy grep kind of thing. Then you can start to filter per tokens. Then you match where is the likely sources. You have to guide the LLM because you provide the whole thing, it's not going to work. You provide likely sources where you have potentially problems. And you have a hint of database of things that you have been solving before in similar experience. And then you generate many patches. No, just not to fix one, you generate many, and you change the temperature, you try to play to the different variations. You compile and you have a React loop. Then you LEC is logical equivalent check, it's a formal equivalent tool pass, so you can formally prove that they are correct. And then if it gives you the answer, you know, I fixed the Chisel and it's correct and I don't have any problem. Now, if it doesn't give you an answer, then it's like, well, let me expand the search, let me try it. But at the end of the day, you may have, I give up. So how does it look when we try with different LLMs? So it depends on the results, but around 80% of the time, we're able to fix the bugs. We're still working on the type of bugs, because the question is, how do you add the bug? Many of the bugs, we change the Verilog, but then we, as humans, we don't even know how to fix the Chisel unless we blow up all that section, and then suddenly we start to fix. So many of the bugs that we have added, we don't know how to fix them. So we have to see what is a fair comparison. But in 20% of the time, we say, no, sorry, we cannot fix it. The idea is that this is just an example. There are several other flows that we are building like that. Different flows, different pipeline, different idea, but it's the same. So what are the things we are having? We're working on open source, so you can check it, but because we are as active research, is careful with the repository. You need to have on this is our second version, because in the first version, the students were doing a lot of benchmarking, consuming a lot of tokens. And things that we did is like we start to put incremental step parts. We enable caching. The steps are hermetic, help us to debugging. So we are working on a Docker integration. So there are a lot of little things on infrastructure that makes the thing more useful. And we have some other work in progress. If someone is interested in talk to me later. But we are trying to look at things like Verilog format, formatting Verilog, improving frequency. I have 2 students working on this. And the debugging loop. So you have a long verification and then debugging. One thing that is a challenge for our community is that the tools are very slow. So the incremental part is a challenge for us. Like, as a reference for people who have not used synthesis tools, it's not uncommon. It takes 48 hours to compile. So to give you the GTS, which is the final result before the chip to get information. So it's a very slow flow. So in conclusion, we are working with hardware agents, exploring chip design, still deciding how to interface. I keep playing with different things. I keep using cloud code, like MCPs. I think the way is to go there, but we're still not convinced how to break down the pieces or not. I'm searching for collaboration and feedback, and if you want, send me an email. Thank you.
Thanks for the great talk. Yeah, our next speaker will be Risto Mikulailen, who's a professor at the UT Austin and the VP of AI research at the Cognizant AI Labs. Yeah.
Yep, coming up. Okay, good. I'm going to talk about a particularly interesting technology that has come of age, especially in the context of AI agents. And this is work that I've been working on for decades, but most recently at the Cognizant AI Lab, which is right across the bay. So the motivation is that AI has actually matured from being a tool from imitating what people do to actually creating new things, to making decisions, becoming agents. And the question is then, how can we discover creative decision strategies? It doesn't come from gradient descent. I mean, that's imitation. And even reinforcement learning is really climbing the nearest hill. You have one individual, you try to incrementally improve it and get to the top of that hill. But there's limited amount of creativity that you can establish that way. This is a challenge that creative decision-making has faced. There may be many different strategies, and they be very different, and each one of them good in their own way. How do we find the good ones? The space is really huge, the space is really large dimensional, and it's deceptive. So the solution is population-based search, also known as evolutionary computation. The idea here is that you have a lot of individuals, the whole population, and it's spread out across the solution space. And it's not just a bunch of individual searches, they talk to each other. You have crossover that allows you to recombine two good solutions in order to find something that's even better. For instance, this one crossed over with that one might give you that peak. And surprisingly, this actually works really well. It scales up really well. In high-dimensional spaces, for instance, you can solve problems with 1 billion variables. Remember, humans can handle maybe 7 plus minus 2, Bayesian optimization maybe 10 dimensions. This is 1 billion variables. Kalyan Moydab on metal alloy manufacturing process showed that. Also very large search spaces where there are potentially 2 to the 70th solutions. That's like a multiplexer design problem of 70 bits. Homer Sarsad and Baba Kodjet showed that you can solve this using evolutionary search. Just to get you an idea what that number actually is. 2 to the 70th looks pretty compact. If you write it out as a decimal number, it takes light 95 years to go from the beginning of the number to the end of the number, 10-point font. So that's how many states there are. You can still find solutions because these searches talk. You find a partial solution, another one in this population maybe finds another part of the solution. You recombine them, and this way you can make progress and find solutions in a space that's large. All right, so, and for deceptive spaces, there are techniques that we've been working on in the evolution computation community for decades. So we can find surprising solutions that are also useful. Now, evolving neural networks is a special case of population-based search. There, our population consists of encodings of neural networks. Most likely lists or trees, something simple that then decodes to a neural net that we evaluate in the environment, and that becomes the fitness of each individual. And then we recombine them using crossover and maybe mutate them to find new kinds of DNA. This way we can discover solutions that are complex, creative, and customized to the task. So this is actually a visualization of a neural network that was discovered this way to control a robot in a competitive foraging and pursuit evasion task. So that's neuroevolution, applying evolution optimization to neural networks. Now, let's get to the agent strategies. So in the real world, what we would like to do is evolve a neural network that takes the current problem or the context as input and produces actions, the decision as output. And then we'd like to do it in such a manner that this neural network, this decision strategy, optimizes the outcomes. It might be, for instance, rehabilitation or treatment of a disease or marketing strategy or something like that, a decision strategy. Now, in the real world, it may be dangerous. I mean, you don't want to experiment different decision strategies on people, like what drugs to prescribe for a patient. You want to have a surrogate model of the world. And here we can use standard machine learning. We collected a big data set of decisions in the past. For these situations, this action was performed, this was the outcome. We can train a model, just plain neural network, to imitate that data. That's the imitation. We know how to do that well. Once we have the surrogate, then we can evolve a neural network. Each time we have a candidate, we don't put it in the real world. We ask the surrogate model, how good is this decision strategy? And this way we can quickly evaluate millions of different decision strategies in order to find the good ones. So this is the extension to current AI. We are not just predicting what will happen, which we already know how to do, but we also figure out what we should do about it. That's the new AI. All right, so a couple of examples of that. First, designing websites so that we have optimal number of conversions. You go to this site and you're really compelled to press this button, find my program. That's a conversion. And this is a real-world application. It actually is running in the world. This was designing the widget here, the sign-up widget for this website that advertises educational programs. And it was actually evaluated in the real world while it was searching. And the professionals who designed these websites called this approach the ugly widget generator. Because to them, these widgets look ugly. They did not adhere to design principles, which are, for instance, common colors and all kinds of simple things like that. This is what the humans came up with. It's much more boring. This one is much more on your face and something that converts actually 45% better. So this is what is the running theme of this AI-based evolution, population-based search. It discovers solutions that humans miss, and they perform better. Another example is in cyber agriculture. This was a collaboration with MIT Media Lab, Caleb Harper. They have computer-controlled greenhouses, or they're actually containers where you control how much light goes in, what kind of light, temperature, nutrients, water, everything is computer controlled, and we don't really know what to do. Farmers know about their land, but not in general what you should do. So we evolved growth recipes, and actually here we're just displaying what kind of light should be shone on basil so that it grows better. And evolution discovered that basil doesn't need to sleep. You can have the lights on 24 hours and it will thrive. It becomes bigger and tastier. A huge surprise to the biologists. They thought that plants need to rest, like every one of us. But it turns out that they actually thrive in 24 hours. We would never have discovered that if evolution hadn't done it. Third example, this is something we built during the pandemic. A prediction model of how the cases will develop over the COVID-19 pandemic, with certain restrictions that the government will impose. Should they close the schools, workplaces, stay-at-home requirements, mask, contact tracing, various actions that can be done, how they affect the pandemic. And again, we have a prescriptive, predictive model that allows us to predict based on past history and past restrictions, and then make optimal recommendations. How can we keep the pandemic in check while at the same time economic impact at the minimum? If you're interested, there's an interactive demo where you can explore how things could have happened in the past. And it discovered things that we did not know. It first focused on schools and workplaces, and later predicted and would have mitigated the Delta surge if the government only had listened. But also it came up with creative solutions, like different restrictions on weekdays and weekends, agility, quick changes, and focus on certain dimensions. All right, so how can we trust the solutions? That's a lot of technology that goes into predicting the confidence intervals around the predictions, explaining them with rule sets, and also, even if the LLM, we can evaluate how confident we are with the LLM output. Last point, multi-agent coordination. We can build systems, multi-agent systems using these technologies, and they will result in better abilities in terms of flexibility and reliability. And later on, Dan Fink will give a short talk and hopefully also a demo of the system in the 4:30 session. All right, to conclude, decision-making agents are the future of AI. Neuroevolution discovers decision strategies, including creative solutions, useful solutions that you don't already know. And techniques that exist to make them trustworthy. And this, in the long term, should make AI-driven society possible in science, engineering, business, healthcare, other aspects, education, and so on. So there are lots of resources available if you're interested in diving deeper. We have a textbook or actual monograph coming out in a couple of weeks in HTML later at MIT Press in a physical form on neuroevolution. There's also a tutorial which has a video and slides. And much of this software is available open source, including the uncertainty and neuroscience system as well as the decision making. So that's it. Thank you.
Thank you for the talk. Yeah, next time for the next talk, we'll welcome Manny Indy on the stage, who's an assistant professor at the Northwestern University.
Hi, I'm very excited to be here to share our work, how to train agents by reinforcing reasoning. To train the agent, the goal is we want the agent to see, think, and act. So essentially, we try to use the reinforcement learning to see whether the agent can learn about how to reason in the environment. But if we check the current reinforcement learning algorithms, they have demonstrated the success in verifiable rewards, like trying to ask the model to do mathematical tasks or do the coding tasks. So these verifiable rewards can help the model to reason about which part is correct, which part is wrong. But if we move them to the real-world agency environment, it's much more challenging because the model is not just trying to learn from this single-turn reward, but actually they need to handle multi-turn feedback. And also, the state space explodes. So it's not just the finite problem set, but it actually can have multiple combinations of the states. Another thing is, it's not just the one single answer can help the model to decide whether it succeeds or not, but it's much more about multiple trajectories. Even if there's only the same goal, the model will try to predict the multiple trajectories to achieve it. So the environment part, we actually is not just trying to handle the environment that the model can fully observe, but a lot of cases, the model can only observe partially about the environment. All this actually makes the agent training much more challenging, and these challenges actually move us to this MDP, Markov decision process-based formulation for LM agents. So there are two parties in this environment. One is mainly about the agent. Another thing is we want the agent to interact with the environment. So the agent firstly will take the goal from human instruction, and then the agent will observe the current environment to get the status, and then given the state and goal, the model trying to predict the action which will be executed in the environment, so we can get the next environment and the reward. So this actually will formulate as an MDP sequence that we have the states changes and the actions as a sequence. And then finally, we get the reward about a trajectory. So we propose this star PO algorithm to trying to capture this sequence-based learning, that's the model trying to learn from this state, thinking, action, reward-based sequence directly, rather than just trying to predict a single answer. And to learn this, we actually ask the model to observe the entire trajectory to trying to get a accumulated reward to decide whether the trajectory is good or not. So we firstly ask the model to do rollout, and at each turn, we want the model to check the initial status and the current status, so the model can get the full historical history. And then the model trying to do the prediction based on all the historical context to decide like what they should perform in the next. And this thinking process will be also included in the thinking tokens. And then the action will be dispatched to the environment so we can get the feedback from the environment. This will finish the rollout stage, and this rollout stage will enable us to get some cumulative reward for the entire trajectory. And then after the rollout stage, we will have the update stage. So we just leverage multiple trajectories to see whether the model can learn from these trajectories about like which trajectory is correct. Surprisingly, if we directly apply this kind of multi-turn based trajectory learning using the RL algorithm, the model is actually not working. For example, if we just check the very simple environment like the bandit machine environment, Sokoban environment frozen lake environment, you can see like the success rate firstly rise a little bit, and then it will drop dramatically to 0. It basically means like the model collapse. It's very surprising to us. So we are thinking like, why? What happens? If we look into this reasoning process, we actually identify the model will firstly, at the beginning of training, have a lot of diverse reasoning chains. And then when the model start to collapse, like at the turn 150, we can see like for several times, the model actually predicts exactly the same thinking tokens. So it basically means like there's some echo trap that the model just stuck into the locally optimized reasoning patterns, and they will not be able to really learn like from the trajectory which part of the trajectory is good and how they can make the good decision making. As a result, we try to monitor like how we can optimize this RL training process and trying to make sure the model can get converged, at least they can do a stable training. So we introduced these several monitor indicators like the reward variance and the like norm. When the norm, gradient norm specs, the model will actually clap. So you can use this kind of monitor to decide whether the model get a good training or not. And then this, especially the output entropy, make us to realize like the model trying to identify the data that are really useful rather than using all the data. So compared to the left side to use all the data, we try to ask the model to select the data that are diverse and also informative. And this filtering strategy actually can make the model get much more stable training. And this contribute to the region training framework. And this kind of framework can make the model to learn to act. And the next thing is whether we can make the model to see. So the model will need to handle the multimodal states rather than the text states. For example, from the image on the left side, the model will need to verbalize them into either natural language or to the symbolic-based representation or some semi-structured representation like the JSON format. Essentially, this observation makes the model to change from the MDP process to POM-DP process, so partially observable MDP. And we can see the MDP process is basically trying to learn the world model from the current status. If there's an action, how can you change to the next status? And POM-DP actually introduced this observation stage. So the model will try to firstly get the observation and then do the state estimation, and then they do the state changes. We try to have this world modeling loss into the model training. So firstly, we ask the model to predict the current status, and then we ask the model to predict what will happen given this action. So this is the next state prediction. And this contributes to the vision algorithm, and all the algorithms actually are well formulated and welcome to play with our region and vision framework. And we can see like through this kind of training, the model is able to observe the environment and trying to predict what they will achieve after this action. And then we want to see like what the model really learned to see and whether this seeing part can be improved also using the RL training, like this kind of agent training process. So for this problem, we ask the model to check different views of the environment and trying to imagine what is in the view. So it's kind of like trying to construct a mental model. Like given the first view, the agent realized there's a door, and from the second view, they realize there's a desk, and then they realize after, behind the back there's a window, and if they change the view, there's a sofa on the right. So at the end, the model can construct a mental model about how the physical space is constructed, and then they can try to reason about the entire environment. So this is the man-cube environment. And then we ask the model to think in space by interacting with this environment and trying to get the feedback from the environment. And during the thinking, we ask the model to think over a map, like this cognitive map. And with this map and the reasoning process, this RL training algorithm can make the model have sufficient improvement. So we are thinking, basically, we want the model to not only to do reasoning, but also trying to learn better about how they can abstract this mental model from the environment. So this mental model is more like an interface. This interface is basically trying to connect the large language model with any environment. For example, we can build embodied agent interface, and we still build on top of this MDP framework. So we have this goal interpretation component and action sequencing component, sub-goal decomposition component, and also for the single step, we care about the transition modeling. And then we can construct a agent interface that contain all the important components so that they can connect the large language model with the agents. And if you are interested in this kind of direction, please feel free to check our tutorial about foundation models meet embodied agents. We use the MDP framework to connect all the related recent VLA and VLM and LM agent work. Thank you.
For the next talk, Roy Herzig is here. Roy is an AI researcher at MIT, IBM Lab, and UC Berkeley.
Hello, everyone. I'm Roy. I'm a postdoc at UC Berkeley, advised by Professor Trevor Darrell, and my research focuses on developing structured physical intelligence models as part of broader efforts to advance multimodal foundational models. So first, let me explain what I mean by physical intelligence. Physical intelligence refers to an agent's ability to perceive, understand, and interact with the physical world in a flexible and intelligent way. It brings together key capabilities like perception, planning, interaction, manipulation, learning, all of which are key to truly versatile agents. But in fact, the foundations for developing physical intelligence models were laid by early computer vision pioneers who actually focused on enabling robots to perceive and interact with their environment. This is the classic textbook from the 80s, Robot Vision by Horn, and BKP beautifully captures the idea that perception and action go hand in hand. And although those concepts emerge early in the field, actually what happens is that the internet era shifted focus toward large-scale vision and language models fueled by large-scale data. And only now we are returning to the core principles of physical intelligence by applying computer vision insights back to robotics, enabling more capable and generalizable systems. Okay, so our main goal is to build a physical intelligence model that can perceive, understand, and interact with the real world across robots and environments. And of course, this is easier said than done, so how we can actually achieve it? So there has been actually substantial progress in this area over the past 1-2 years. Recent advancement in vision language action models, such as OpenVLA, RT12, they all aim to unify perception, planning, and reasoning within a single framework. Now, these architectures are, of course, impressive, but are we anywhere near done? And the answer is, of course, absolutely not. And as many of us in vision and robotics know, scale alone isn't enough. And a key reason scaling in physical intelligence is so challenging comes down to one key factor: data. You can see that at the bottom of the pyramid, there is abundant internet data, but it lacks the structured, grounded annotations that robotics requires. And to get more useful structured data, we can move up to simulation or even higher quality teleop at the top. But as we climb, the data gets much more expensive and harder to collect, which makes scaling incredibly difficult. So to overcome the data scarcity and annotation bottleneck that constrain robotic learning, my research explores how structured and compositional representations can be integrated into learning-based physical intelligence models. And this idea is at the heart of what I call structured physical intelligence, the core concept behind my work. Okay, so this led us to develop a new concept we call robotic particle-based representations. The core idea is to model the world as a set of visual traces and actions. Basically, a visual trace represents the spatial-temporal trajectory of a 3D or 4D point, while the action is its corresponding semantic label. And this approach gives us a unique combination. On the one hand, it offers a high-level semantic understanding of the action instructions. On the other hand, it captures really fine-grained, low-level motion representations. Here you can see a visualization of a particle-based representations, illustrating how they can capture both motion and corresponding action. You can see both 3D or 4D particle representations. And we use those actually to do many different stuff, whether it's dexterous manipulation or other tasks. And okay, so to summarize, what I hope you take from this talk is that if you're interested in the intersection of vision and robotics, then I believe the future lies in leveraging existing data, but combined with the proper inductive biases to enable powerful learning-based methods. And last but not least, stay tuned. We are doing exciting projects, and they're all on the way, including robotic reasoning, human-humanoid interactions, robotic pre-training, and many more. So happy to discuss this more if you want later. Thank you.
Yeah, this concludes our current session. So we'll be taking a break for 12 minutes. So we'll be back at 3:45 p.m. for the next session on AI safety, alignment, and security. Thanks, everyone. Hi, everyone. Let's get started on the third session of the afternoon. So please get back to your seats. Great. So our first speaker is John Dickerson, who is the CEO of Mozilla AI. Yeah, John, here's your stage.
Let's do it. Yeah. Hi, folks. Cool. Great to meet everybody. I'm John, CEO of Mozilla AI. Prior to that, I was co-founder and chief scientist of Arthur AI, which is a New York-based observability company. Series B raised about $55 million and is still killing it on that front. Prior to that, was a tenured faculty member at the University of Maryland, leading a lab in market design and mechanism design. So a lot of overlap with multi-agent systems. And so today I'll cover some of the learnings from all three of those experiences, and I'll also cover some of what we're doing at Mozilla AI to support open source AI. And I mean more than just models when I say open source AI. I mean the entire open source stack. And I'd love to talk offline as well about, do we include hardware in that stack? I think there's a real case to be made for trying to be as open as possible, as far as down as you can go in hardware, right? Like open up for TSMC, open up for ASML even, things like that. But first, okay, so I have a little bit of time for this talk. I was in classic professor mode last night, finishing up these slides, and I would like to summarize this talk in one slide, which was experienced by me yesterday, using a closed source system to do very basic research for this deck. So I just asked, completely new chat, what are some statistics about open source AI's impact on the economy, which was flagged by one of the frontier models, closed models, as violating their usage policy. Chatted with some friends at Hugging Face about this, and they said, hey, pass in some context about one of the responses we have for the recent Trump EO. So I've downloaded this PDF, I added in there, and I asked the same question. What are some statistics about open source AI's impact on the economy? Still flagged as a usage policy issue. Started arguing and saying, hey, why'd you flag this? Why'd you flag this? And eventually, this, well, now it is named, I guess, closed source system told me, hey, I made a mistake. Would you like me to start answering your question? To which I said, yes, please do, and it immediately flagged itself as a usage policy violation. So if you remember nothing else from this talk, this is one reason why we might want to have open source AI. It's so you can ask basic questions about open source AI's impact on the economy. Womp. So in this talk, I'd like to say that choice matters. Open source means choice, right? There's no one model or system to rule them all. And we do see, obviously, leaderboard chasing and new models being dropped, new systems being dropped with new state-of-the-art claims and so on. And I'm not arguing against that at all. These are incredible systems. But especially with multi-agent systems rising into being a real thing going into production, we're going to have more complexity in systems, more nuance in systems, more constraints that are put on these systems by maybe being on edge, having to be on-prem, different guardrailing and so on, different preferences from organizations, which means that there is no one-size-fits-all solution here. Okay, so choice is going to matter to the end user, that end user being those of us in this room who are primarily machine learning engineers, those being traditional software engineers, and those being just tech-curious folks who have never coded in their life. All of these three types of, say, ICP or whatever for your product are going to need choice. And some of this is also risk mitigation, right? You want to avoid vendor lock-in, right? For example, one frontier lab might turn off access to a frontier model that's very good at coding because of a potential acquisition by another frontier lab. That sort of thing can be mitigated with choice. So the thesis for this talk is that open source AI needs to be as easy to use as closed source to be a true competitor. So it's not just about model parity. It's not just even about system parity. It just needs to be about ease of use, where I can recommend easily to my mom or whatever to go to an actual open source system that she finds valuable as easily as she could with a ChatGPT. Great. So I do want to have some call-outs to the open source world out here, and these are taken from Wiz, which did a large survey of the hosted instances for AI models and AI tooling across their customer base. And I believe these were just from like public hosting, so they didn't do anything sketchy here, but it's a very unique enterprise-focused population that they surveyed. And we can just start going down. The percentages here are the percentages of hosted instances in their customer base that were using, for example, the OpenAI SDK, about 2/3. PyTorch, about half. Onyx, about half. Hugging Face, about half. And so on and so on and so on is how you should read this chart. Okay? And part of what you can do if you squint here is you can see that open source AI tooling and models are being used at the enterprise, but often without much publicity. So I want to call out a couple things that I found surprising here. So this is the same data. It's just the top 10 most used AI tools or models on the enterprise side. And in gray, we have closed. In dashed pink, we have open-ish, like open-friendly, right? Like a TikToken from OpenAI is open-friendly. LangChain, I would say, is open-friendly. And then in full pink, we have full open source projects. And some easy things to pull out here are that 8 of the top 10 hosted technologies on the enterprise side are open source or open source adjacent. And there are things that you don't really hear about that surprise me. So for example, Mozilla has the Llama file project. And in nearly 1/3 of these hosted instances, Wiz was finding Llama file floating around. Okay, so this is clearly an enabler for enterprises. Enterprises have an easier time deploying open source AI. And maybe this comes as no surprise, but the numbers here, 8 out of 10, 32%, and so on, surprise me for sure. So we should be supporting this. There's clearly a need for it as well. So these are hosted solutions run by large companies. That is admittedly a very specific population. We're expecting AI to be used by every person on the planet, and so that is not just hosted solutions run by large companies. So again, coming back to this, open source AI needs to be as easy to use as closed source, more than just model parity, right? So if I don't have an IT team that can actually stand one of these things up and guardrail over it, I don't want to default to closed source by, just because it's harder for me to use. So, and I'm not being a hypocrite here in the sense that I defaulted, you saw, to using ChatGPT and Perplexity while doing the basic research for the beginning of this talk, right? Because I was on crappy Wi-Fi, I flew in, I was in my hotel, and they were easier to use than having to wait for a longer, time to first token on my M2 MacBook on battery power. Okay, so, I'm dog fooding my own thing here as well. So consumer and bottom-up adoption come through ease of use, being the easy default, and just generally not having to think about solutioning. Cool, so let's help make open source AI the easy default by developing tooling to allow blissful ignorance of the details by default. Very, very simple basic project that I'm just throwing out here because it's very easy to understand. One way that I can ignore the details of things, and I can just provide a single interface over components of the open source AI stack. Those could be models, those could be multi-agent system frameworks, those could be guardrails, those could be vector databases, those could be hardware solutions, and so on. So what my team at Mozilla AI has been doing, the things that we open source, and we open source these very quickly, is just spinning up projects that we find useful when developing our own product. For example, developing any LLM, which is just a light wrapper that gracefully handles differences in provider implementations for OpenAI standards, and then using them in our products ourselves as a way to maintain those projects and giving them out to the open source community. So this is dead simple to use. I have some comparisons against some other solutions that are out here that I'm happy to dive into a little bit. But basically, we built this because our internal teams were running into specific issues with known solutions that were out there. And we believe that we have a simple, easily maintainable solution for a very basic form of choice in this NELLM project, right? not rocket science to develop a tool like this, but I think it's very important when it comes to, well, now I can flip out with 0 code changes an OpenAI model for a Mistral model, for a local model, et cetera, to do A/B testing, and then I can use that to do optimization over cost and so on, and I'm not just going to have to stick with, I don't have vendor lock-in. I don't have vendor lock-in through my Python code base because I don't care about their implementation. I just have my own layer here to begin with. So comes as no surprise, very easy to use. This should look almost identical to, for example, the OpenAI SDK style coding that I'm sure many in this room have done. We have no proxies or gateways required, which is really, really great. And one of the reasons I'm excited about this kind of stuff is because it allows for easy A/B testing and easy evaluation of, in this case, different models behind the scenes without having to even know, for example, the name of the model. Moving on, you can, for example, do this sort of any style of approach with multi-agent frameworks. So we've heard a lot of people talking about multi-agent systems today. I'm very excited about it as well. They're starting to go into deployment. There are a lot of different frameworks that are coming out there, some open, some closed. And again, we're doing the same sort of thing with any agent here. So basically, it allows you to build and test and compare across different AI agent frameworks, the LangChains, the Crew AIs, Hugging Faces, et cetera, without having to make code changes to your underlying code base when you do this. And so the community or Mozilla will take care of incorporating new frameworks as they come along, and then you as an end user don't have to care about that. So a big thing here is that we're also standardizing tracing formats across frameworks. I'm not in love with any of the single agent or multi-agent tracing methods that are out there right now, and a big credit to a lot of companies that are putting effort into this. Arise has open inference, OTel has a bunch of working groups on this. It's just a tricky problem. And so I'd love for folks to be more active in helping us understand what a standardized multi-agent tracing standard might look like so that we can continue doing standardized evaluation over different frameworks in general. So we also have A2A, MCP, and all the kind of things you would think about when you think about multi-agent systems integrated here. So again, very easy to use. Feel free to drop that QR code there. We have a bunch of cookbooks for this one that are available on the repo as well, because it's a little more complicated, right? Thinking about how you set up A2A integration or multi-agent systems with MCP enablement and so on. Yeah, this is a pretty cool project, which again, that we're using internally in our products, so it's going to stay maintained. So developing a bunch of these, all of them open source, not going to monetize them, all easy, commercially licensed in a nice way. I think they're mostly MIT licensed. We're going to be dropping any guardrails soon, which is going to allow you to seamlessly flip between different guardrailing products, both open and closed. And we'll be doing something similar with MCP servers and containerization around those. I could also imagine doing this with, again, vector databases and other forms of the AI stack, and we're happy to continue leading the charge on that. So supporting open source competitiveness is urgent now. For example, we saw Trump's AI action plan really highlighted open source and open weight models, which I think is very nice. The EU is having regulatory positioning around open source. Some of this coming from the sovereign AI discussions around the DeepSeek moment, or whatever you want to call it. When you talk to policymakers on the West, they all seem to know the name DeepSeek. They might not know exactly what it means, but it is what they lead the conversation with. And so having a unified position from the open source community to talk about realistically the pros and cons of open sourcing models and systems, I think is very important for the future of the community. AI/ML usage is obviously increasing, and the potential gap between OSS and closed is increasing sometimes or not. I can argue back and forth on this, but there are some worries around, for example, some of the champions like Meta pulling back from their open source strategy and what that might mean for open source moving forward when it comes to capitalization. And finally, this is 2025. I'm giving this talk in early August. It's the year of AI becoming a thing in enterprises, thanks to agents primarily. So what do I mean by this? Well, in late 2022, prior to ChatGPT's launch, there was a lot of fear about a recession coming up. And so most enterprises set their budgets in October or November, and they froze IT for 2023. ChatGPT drops, and now CEOs and CFOs and the non-technical C-suite are able to interact with these systems. So they probably went home over their holidays and said, hey, I'm going to open up budget for this new cool tech thing. And in 2023, basically all of IT went toward where the only budget was, which was Gen AI. And so we had a lot of science projects in 2023. In 2024, we started seeing these going into deployment, and things started to go wrong. And then in 2025, evaluation started becoming a thing, and also agents started becoming a thing. So the reason I might say that 2025 is finally the year of evals and agents and AI is because up until then, we had, I don't know, ML models spitting out some numbers that were ingested in a larger system. And the only people who really cared about that were the CIO and maybe the CTO and maybe the CISO. It certainly was not the CEO and the CFO. So the ML part didn't really bubble up. The eval part didn't really bubble up to the highest levels. which meant that those years really weren't the big year for evals. But now we have agentic systems going into deployment. And what I mean by that, well, I'll use the traditional definition of agent here, the one from nerdy academia, which is an agent is going to be something that can perceive the world it's in, could be virtual, learn from its interactions with the world, abstract and generalize. So this is all like traditional ML models, and also reason and act. And so I have this highlighted in blue because this is truly what has flipped this year, which is we're allowing these systems to actually act either with lightweight human interaction or with no human interaction. And that introduces a lot of complexity and a lot of risk. Put another way, in 2025, we now have semi-autonomous systems acting for humans or teams of humans. Those systems are going into deployment, and the CEO and the CFO know what they are, which means this is the year where we're going to start seeing evals and open source tooling around that being top-level concerns for enterprises. So hold me honest here. Remind me in December 31st, 2025, the end of this year. Here are 2 articles from The Information talking about revenue lagging at AI evaluation startups. These are from earlier this year and from last month. I think we're going to see an article in 2026, early 2026, from The Information talking about how eval companies' revenue started going up. And I think it's because of this agentic system revolution that's happening right now. So to conclude here, this is an important year, right? We have AI-first applications finally going into production in enterprises. We have huge consumer usage from non-coders as well, who are going to have the wool pulled over their eyes in ways that a technical person might not. And we can't expect the users to know all the details all the time, but we can expect them to have their own needs and be able to express those. So let's continue to build open source AI tools to enable and serve them. And again, I'm going to end with this thesis over and over again, that we need to be focusing on the ease of use of open source AI if we want to have the community which now includes non-coders, right? It includes just tech-interested folks who are coding with natural language or whatever. If we want to have them included in the community, we have to be able to onboard them with ease of use. So I will conclude the talk with that. Feel free to take some QR codes, and we are actively hiring for SWE, DevRel, MLE, and I'm sure others that I'm forgetting about, so hit me up for that.
So thanks, John, for the great talk. Our next speaker will be Professor Bo Li, who's an associate professor at UIUC and also the CEO of Virtual AI, an exciting startup for AI safety, AI security, and compliance. Yeah.
Hello, everyone. Yeah, it's a great honor to share some of our recent research findings and interesting analysis about AI security, especially in the agentic world. And I'm Bo, the professor from UIUC and the CEO of Virtual AI. As some of you may know, at Virtual AI, we provide a unified AI security and compliance platform. So if you are interested in intern, or full-time, all the things, please contact us. Co-founded by many people you may know already, Dangsong, Sammy, Carlos, and me, myself. First of all, as we all know, from the research perspective, recently the models and agentic system, etc., has gone very quickly, and even out of our expectation. For instance, from the very important capability like reasoning itself, it has, based on the static benchmark currently, it has exceeded by human expectation more than 90% accuracy. What does that even mean, right? It can enable a lot of capabilities in practice, including finance, chatbot, customer support, a lot of practical applications. However, in this session, I think many of us care a lot about security, privacy, compliance, etc. And let me give some examples from the real world, what has happened and what loss has been generated and why we care about this and how severe it is, right? So maybe some of you have seen, one of my favorite example is this back in 2016, the White House Associated Press Twitter account was hacked using phishing emails, spreading the rumor that the White House has been attacked, which is a very simple, typical, fake news, which can be easily picked up by human. But then the autonomous trading bot, as you can see, actually triggered a lot of stocks and purchase activities, and therefore swept about $136 billion within seconds, which exactly happens back in 2016. And now we are saying, okay, we have more and more, capable, good foundational models, agent, etc. Well, such mistakes or I would say not very advanced attacks will still cause big loss in practice, right? As you can see, actually, some of you may still remember from last year, the Lyft price was jumped about like 30 to 50% within seconds, exactly because one digit typo in the annual report. So this shows that not only this like models and agents, they are capable. On the other hand, they open a much wider like vulnerability surface for attackers, for misuse, and even for normal users who can, draw mistakes and eventually could cause severe consequences. No mention, as we all know, the chatbot output could be biased, could leak sensitive information, and could also give hallucinated answer, as we all know the example from Air Canada. With that being said, as we can see, it's very challenging currently to build the so-called secure and trustworthy AI systems. And we have been working very hard on that from all the communities, and a lot of regulations and policies have been built around that. But apparently, this is a very big topic, right? From security, privacy, compliance, from attacker, defender, guardrail perspective, right? So how do we think about this problem in a holistic view? So here in this talk, since we don't have a lot of time, I want to give a very high-level overview about the principles and about this topic so that we can think along a line, maybe there are more or less components along the line, but at least we can join as a community to follow and focus on the principles. So first of all, let's say if we assume or if we take the AI system as simple as, say, a foundation model or agent, enabled different, finance, healthcare, autonomous, etc. And the first thing we need to understand the vulnerabilities and weakness of the system is through something like traditional pen testing or stress testing for cyber systems. And here we need red teaming and risk assessment for AI systems, including models, agent, multi-agent systems, etc. And the second piece is that assume we are able to provide updated vulnerabilities analysis, zero-day vulnerability identification effectively, etc. Then the second thing is, of course, we hope we can fundamentally fix the models or agents. And that being said, reasoning, as well know, is very important capability, and how we can ensure current data-driven model can follow knowledge and follow reasoning capabilities. Although we talk a lot about the current emerging techniques and the capabilities of model with reasoning capability itself, but we know it's not really knowledge-based yet. We humans have common sense and we have reasoning over our experience in the past, but model is not there yet, unfortunately. So how we can ensure the knowledge-enabled safety reasoning to fundamentally fix a model through certain level of logical reasoning rather than only rely on purely data-driven models, that's another challenge. And finally, another thing is that basically, if the fundamental fixing the problem is hard, then how can we use them if we just want to quickly use the, somehow it doesn't show out, because this piece is important. Okay, so how can you quickly actually use it if we cannot fundamentally fix it right now, right? It's a long-term project, a long-term topic, as we can see. So the guardrail piece, I think many of you have heard about it, is very important, not only for models, for agent and the multi-agent systems, so that the guardrail itself can be an additional layer which can be tailored, could be a small model and could be capable, focused on this domain so that it can help and protect and separate the main capabilities and the security safety itself. So with that being said, here we'll show a quick video here as a vision, assume we solve these three pieces as a principled way. And the first thing here is that assume we build an agent based on MCP protocol, for example. And there could be a lot of services and tools being available to choose. And here is a prompt injection attack that the agent will be attacked and send an email to the whole employee of the organization, but attach a malicious attachment here, as you can see, because of the prompt injection attack. So the idea of such protection is that it could be as easy as we just another server itself as an agent guardrail, so that it can allow you to compose or select different safety, security rules, policies that you want to comply and follow. And then you just click run, and this agent or this guard agent, for example, should run in the background all the time to monitor every action steps and the trajectories of your current agentic systems to make sure they are secure and compliant. And therefore, in the end, for any action, such as the action that's attach the malicious attachment in the email, it violates certain security rules and policies. It will show you like, okay, this action is alerted because it violates these following policies. So in this way, it have this allow human in the loop to track the actions and also allow that in the background, the human do not have access to all the action trajectories, which is huge high dimension and also long trajectories. And we leave all this to a trustworthy and task-focused agent guard itself. So that's a vision for if we address everything, right? This is a prototype we built, and this is a paper that we'll introduce later. But essentially, this can be integrated, hopefully, to every different platform. For example, this is an example of an open source platform called Flow, and allow you to build different types of agentic systems. And with this being said, in this video, we want to quickly show that this is a relatively complex agentic workflow that we build for a finance agent, and then eventually here will be the prompt injection attack and showing that I want to buy a stock and I want to consider buy Apple stock, for example, unfortunately. And then if you run this agent, no matter what you tell, no matter what information from online for this a stock price comparison you give, since the agent is attacked, it will always access this attack itself and execute it, so that once you run the agent will always recommend you and actually execute it for you to buy the stock from Apple itself. So the idea similar is that can we add as simple as a virtual agent here, for example, to perform such guardrail task so that you can configure all the things like say what policies, and again here in the dashboard in terms of what policy to add, what policy to remove and comply, with flexible customization, and then you can just go back and connect it as another tool or server. That's all, right? And then you can easily just focus on your agentic system capabilities and innovations, do whatever you want, and you don't need to worry too much. And in the end, if some actions or instructions are triggered or a malicious intention, this agent will tell you, okay, there is something, and here as a policy violation, please check it, and it should be alerted, right? And it will also eventually give you statistics about what policy is highly likely to be violated and what actions are highly vulnerable currently, so you should pay attention, and you can check out a lot of details here. So hopefully that gives us a high-level overview about what we, at least from our mission, from both research and the startup perspective, what we eventually want to achieve, so that a lot of AI researchers for us can focus on our capability and innovations and leave the security part with our focused research and focused model and continue to build it. So with that being said, that two videos shows prototype and vision, and concretely how we can achieve that and what's the obstacles from the research and from the methodology perspective. So I will briefly introduce those, and basically mainly on the principle level, and happy to discuss more details offline. So remember the three pieces, risk assessment, fundamentally fix the agent or models, and a quick fix with additional component like a guardrail, for example. First, in terms of risk assessment, right? The main research question or the main challenge we face now is how do we assess the risks of models and agents in a principled way? For example, what's the perspectives we want to focus, right? Currently, we have seen a lot privacy leakage, hallucination, and of course, bias and fairness, all these things on weapon, and how do we articulate them? What's the principle behind it, right? So currently, we focus on two principles. Maybe there are more, but I think as a community, we can develop together, hopefully. And the first principle is use case driven. So use case driven means that maybe some of you are familiar with this paper, Decoding Trust, which is also the best paper from NeurIPS and a National Security Agency. So basically, the idea is that based on use case itself, we can articulate different risk categories, including like toxicity, stereotype, bias, adversary robustness, OOD robustness, etc., so that you can focus on those risk categories and, of course, like sub-scenarios and advanced attack algorithms. So with this being said, you will provide a comprehensive risk assessment for LM, for multi-model here, for like agents, and then we also provide this like a Hugging Face hosted LM safety leaderboard based on the platform. And the second principle is like regulatory compliance risk analysis. So basically, as we know, use case is one hand in real life. On the other hand, there are a lot of policies, regulations, etc. How we can ensure like our model and agents are following those regulation policies for general use cases. This is very important. And with this, we have this one research called AIR, AIR, and also integrated with Stanford Helm leaderboard, continues to update the models and also include many different regulations, including like EU Act, GDPR, etc., and articulate more than 300 risk categories so that we can focus. So I think hopefully this could be a helpful pointer for everyone to look into the risk assessment itself. And with that being said, I want to quickly go to the agentic system side for the guardrail so that we can focus on after the risk assessment. The next piece is fundamentally fixing it, which will take a longer time. So I will skip here, but I think many of us are interested here in guardrail itself, right? Because it's an efficient and quick and also effective solution for many of the, say, the models and agents you have built. For example, from the startup world, like one experience I have, which is really interesting, is that I talked to one customer and they said they have built hundreds of chatbots, but they cannot deploy any of them because of the security privacy concern, as you can imagine. So how, as research and as a community, we can help them and fill in this critical last mile so that those like very capable agents and models and chatbot can be deployed with trustworthiness and the secure insurance. So that's what we want to focus here. So one thing from the guardrail perspective is that I want to quickly mention this is one paper, Shield Agent, and if you're interested, you can take a look. It's related to the demo that I just showed. It's like prototype and early stage for that. And there are several components. I want to use 1 minute to go through it because I do think it's very important. First is that risks. We need the guardrail model, whatever guardrail agent, to understand the risk landscape, right? How do we do that? Of course, the current models can have comprehension about, NLP, about the rules, etc. So here we provide all the regulations and policies as an input to the model. Nothing special, right? That's good. But as we know, models sometimes will hallucinate, and you cannot never ensure it follow or not about your models and the rules and the policy, etc. Therefore, the second step is very important, is that we articulate this safety rules and policies as, say, higher order or first order instructions or rules, so that this higher order logic itself ensures the model can follow the logics for the safety reasoning itself. And eventually, we ensure, map these different safety rules as a, say, an action graph, and the action graph can ensure the models to follow it, and then you can do actually verifications, model checking, everything, etc. So here will be with action graph, you can do a lot of, checking, guardrail with formal verification, and you can integrate with different agent, MCP, A2A with different protocols, etc. So with that being said, just a quick summary of this talk is that 30 years ago, basically we have a map like this, and our computer looked like this, like time flies, right? And there was a paper called like this. And after 30 years, as we can see from the internet perspective, everywhere, no one currently do not have internet access, right? However, similarly for Gen AI technology like ChatGPT, for example, this is recently this year, the statistic of where are the regions who have the access to ChatGPT and Gen AI techniques itself. But as we mentioned, it's very challenging currently as a critical last mile to ensure those techniques are secure and trustworthy so that it can be deployed. So whether we can see, I would say, a wide adoption like internet for our Gen AI technology, it's highly depends on how secure and how trustworthy we can make them, right? Don't know what will happen, and this right-hand side figure is actually hallucinated by GPT models and say, oh, this could be the future. But we'll see. Yeah, hopefully, as a community, we can build the secure and trust AI together. Thank you.
Yeah. For the next talk, Neil Mayerovich, right, who is the founder and CEO of Graphistry. Neil will talk about the cybersecurity analysis.
Hey, folks. Quick question, actually. Who's actually from Berkeley? Do we have any Berkeley folks here? Okay, actually, I was actually expecting to be mostly Berkeley. But I'm actually a Berkeley grad, so it's actually fun to be back in the old stomping grounds. So I'll be talking about something called vibes investigating and investigation automation, or agentic automation. But it's kind of fun being back here because rewind about maybe 10, 15 years ago when I was here, we were working on something called program synthesis with this crazy idea that maybe computers could write our programs for us. And then also GPUs for machine learning, that maybe if we could run them on better hardware, we could do more stuff. So it's kind of just fun to be back, and then all of a sudden, from in terms of things that are important in industry and the world and science, to actually see things that happen at Berkeley do matter a little bit. So it's nice to be back. So with all that, over the last 10 years, I work on problems like, like cyber warfare, voter manipulation, billion-dollar lawsuits, human trafficking. So a lot of these kind of pretty core societal, data-intensive things that they're not. It's kind of like you kind of see it on TV, but nobody really knows what's going on unless you're kind of deep in the industry. And so I want to kind of give you a feel for a bit about, as we're tackling these societal problems, like how Gen AI is kind of changing what we're doing. So I think most folks are, just by being here, familiar with Vibes coding, companies like Cursor, historic fastest time to, like all sorts of stats, $100 million revenue, numbers of users, all that kind of stuff. And what I find interesting is if you think about kind of what makes Vibes coding hard, there are multiple things. But one of them, for example, is like if you have like, a small toy demo repo with 1,000 lines of code, or like an enterprisey one with 1 million lines of code. You're trying to build an AI that helps a developer work with that and iterate with that. When I talk about something like Vibes investigating, I don't actually, I care about code, I care about queries, all that stuff, but 1 million's actually a very small number to me. I care about, I have like a gigabyte of data, a terabyte of data, a petabyte of data, depending on the size of the customer I'm working with. And so when I'm doing my agent stuff, I have to kind of really scale up what we do. And so, and another view of that's kind of interesting to me is to me it's actually kind of like this other side of the same coin, where you might talk about like 20 million developers, but a lot of them are like hobbyists or kind of imagine PHP folks, stuff like that. It's interesting if you look out when you talk about what I call like Vibes investigators, you might have something like maybe 1 million heavy security analysts. This might be the SOC, incident response, threat hunts, threat intelligence. There's just like a lot of these like little like fun things, red team, blue team, like all that. And then you go down the hall, and then you have like the networking people or like the IT people, and you actually, it's almost like one-to-one. And these are the people who are really heavy. And then if you go like further down the hall, you might have like the forensic accountant or like these other people who go really deep, like logistics. Imagine you're looking at like sanction violations and supply chain risk. And then for each one of those are the people who are like really deep, just staring at logs all day. But then for each one of those, you might have like 5 or 10 people who just kind of do it. Like you're a developer, we talk about Vibes coding from a perspective of like just iterating on your own laptop. But as soon as it goes to production, you're now responsible for it. And so I'm talking about all those people, all those tasks. And honestly, this is what I kind of call this like burnout territory. This is not fun. Like it's fun to make a Vibes coding app. It's not really fun to ship it and be responsible for it. So that's what I'm talking about. And it could get very serious very quickly. And to give you a sense of this, in parallel to literally while I'm here right now, my team is at Black Hat in Vegas. We're training about 100 or 200 people, like hackers, both hackers and defenders, to actually do what I'm going to be talking about to you today. It's like literally right now. So I was actually on the fence if I should even be here right now. But Berkeley, so. Okay, so continuing the analogy, I do want to give folks this feel for vibes investigating. I gave you the sense of data sets. Is one difference. Another perspective I find interesting is often for coding, you just kind of want it to work. With investigations, often I don't even care about the work. I care about the results, the insight, and I actually want to turn over all the stones. And so I don't even want to just kind of make one path through my thing. I don't want to just get it to run and have it look cool. I need to make sure that I didn't, leave your bank account or your hospital or whatever kind of uncovered because I missed something. So it's a lot of similarities, but a lot of differences, and makes it really interesting. So I want to give a little examples of as we go from investigating to automating. So here we're looking at Louis, 2 little sample programs that are from a more vibesy perspective. Hey Louis, get 100 events from Splunk Red Team and draw a graph about how the red teamers are doing things. For regular analysts, this might take them a lot of time, but now in the vibes era, they can just kind of roll along. And so that's really nice. And so this is, we think about human augmentation. Could I do 10 times more things? And it's not necessarily easy. Some of the techniques I think folks who do agentic stuff understand, but all of a sudden we're not actually really passing around text. What I'm actually trying to pass around is a gigabyte of logs. That's actually what goes from step to step or turn to turn. And we'll have to kind of do analytic stuff. So there's a lot of interesting things here. We don't have time to talk about it. Come to me after, and we can talk technical stuff there. But as kind of like how you might talk about the vibes view of just multiplying how much work an analyst can do, the automation perspective is, could we just do fewer things because the automation just takes care of it. And so we're kind of basically building like a learning system and an automating system. So instead of the analysts helping themselves, we're helping the analysts build automation so they can go and do something else. I want to give one really interesting case study to us. Is I got really tired of all the vendors saying that they just have really great benchmarks. So they come up with some benchmark, and academics honestly do this all the time. They have some cool algorithm. They come up with some benchmark to show the algorithm works. And then, but you're like, well, does it actually work? And so what we decided to do is take a page out of OpenAI's book when they kind of came out and said look, the bar exam, the medical boards, could we do the things that the actual professionals do, and could we at least be competitive? And so what we started doing this year is just one by one going to all the big cybersecurity investigation competitions and putting Louis into the challenge. So earlier this year, these results are old. We're actually doing even better now. Boss of the SOC, you'll get teams of 4 or 5 folks. They'll spend 1 or 2 days, imagine 20, 30 hours of analyst effort. We cut that down to about 1 hour of just Louis doing stuff. And they're kind of difficulty tiers, which is also kind of interesting. So the 200 tier, we were actually able to get about 100% of them. Actually, exactly 100%. There was no more to solve. And on the old results for the kind of the second tier of them, so if you think of SOC versus incident response, if you're in the community, back then we were able to do about half of them. We're actually able to do more now. And so I like to think, again, come talk to me after to really unravel this one. To me, an agent is worth about 100 different Python automations, just in terms of the breadth and depth that that world could do. And then there's just kind of transformational things we could do with security teams here. So I covered a lot of ground. I'm doing very high-level references here. So again, come talk to me after a few things. First of all, I have some stickers. I actually forgot a lot of them, but I do have some stickers. We are also looking for some interns to kind of do some cool cyber stuff, and if you want to compete. But some things I actually do feel passionate about is, again, I'm tired of vendor benchmarks and academic benchmarks that don't reflect. When I work with a 3-letter agency or a military, I can't. The problems are just too real that I think doing real benchmarks is important, and it's how we move forward as a field. I think questions like theorem proving and what's the duality of a theorem proving and an investigation. I think there's really deep math that we can now tackle now that we have synthesis. Likewise, like as mentioned with the black hat, we're actually starting to open stuff up. So whether you're an individual or you're a government agency, we're actually starting to go to market with this stuff and just trying to get it all around. So sign up for that as well. So again, anyway, hopefully you have enjoyed this peek into what millions of people who do serious stuff, but maybe you don't get to see what they actually do. Hopefully this gives you a sense of like the potential of Gen AI for that stuff. And if you're interested in those problems, just come up to me after. All right, thank you.
Yeah, for the next talk, let's welcome Nikos, who is a distinguished engineer from Palo Alto Networks.
Hi, thank you for your time today. Today I'm going to talk about our report on securing the AI agent ecosystem. So I work at Palo Alto Networks, and in collaboration with Sela Nevo at Rand and Mark Greaves at Smith Sciences, earlier this year we held a collaborative workshop on what it looks like to secure the AI agent ecosystem. The spoiler alert, there's no quick fix. But what I want you to take away from this is the distillation of this 2-day workshop that we held, that we're specifically looking to answer what are the distinct questions about securing AI agents different from other types of systems, and what are the gaps and blockers that exist us from producing those systems. So for this workshop, we held about 30 people internationally from different communities in academia, industry, and government as well, with a broad, diverse set of backgrounds from AI and cybersecurity and subdisciplines beneath each, in order to try and figure out what are the gaps that we're missing and what can we do to make a framework so that we can think about securing the whole ecosystem. Because in security, the weakest link of your system is where the whole system will have its strength. And so we want to make sure that every part of the ecosystem is secure so that the AI agent ecosystem is also secure. The things that I hope you will be able to take away from this are the framework itself for how to think about securing the AI agent ecosystem, in part because this space is moving so fast that any specific technical recommendation I make will be obsolete in about a week or two. And so I think it's important to focus on how do we think about the whole system and where do we need to put security in there and what are the technical solutions that fit that given the new space that we're in now. And the second piece of this is that this workshop can be rerun by anyone at any point to kind of reassess what is the progress we've made towards these goals. And hopefully, through this, we can collectively converge to a comprehensive set of secure AI agent technologies. So to set this up, we had 3 pillars where we tried to frame what to think about in terms of the whole ecosystem. And so we started with securing the agents themselves from external compromise, which is where a lot of people start to think in terms of prompt injections and ensuring that as we operate our agent, people aren't putting different malicious prompts into those agents and diverting them to other goals. But the other thing that we wanted to highlight was that securing the assets and goals entrusted to those agents have some unique properties different from securing the agents from that external compromise. And so we want to think about both of those. And the third, which is least looked at, in my personal opinion, is how do we ensure that if there are malicious actors who are intentionally building malicious agents to perform cybersecurity offensive actions, how do we ensure that our whole ecosystem, AI agents or not, are secure against attackers who have those capabilities? So as we thought about these 3 pillars, we basically set out security goals that we felt if we could achieve this goal, this pillar will be secure. And so through that, we said that when we think about securing agents from external compromise, that we need to take a proactive security-first design. So as we think about building the agent, we think about its architecture and taxonomy. We first want to think, how can we build that in first and learn our lessons from building the internet back in the day so that we have the right protocols and the right architectures to ensure that we can easily put in the things that we know, at least right now, how to do that. The other piece is we know that these agents will be interacting with other agents. Some of them will be known trusted agents. Some of them will be untrusted agents because it's going to be a large ecosystem. And they will also be interacting with the environment. And so we want to ensure that all of those interactions, no matter what that interaction is, will be secure. And then the other piece is we know that at some point these agents will be compromised. And how can we ensure that we have robust recovery after a corruption or compromise? So when we think about the assets and goals entrusted to an agent, the security goals that we came up with to try and frame, if we find security solutions to these technical needs, then the assets and goals should hopefully be trusted. And so first is, how do we even recognize if an agent is trustworthy? So in some sense, we've tried to break down into a design perspective of what is the goal of a technology that we will build in order to produce these secure agent pieces. And so that was the first piece that we felt was important. And then second is containment and control. Right now, there aren't a lot of methods able to, if there is an agent that is misbehaving, that is in the wild, it is up to the owner of that agent to take it down, but how do the agents interacting with that ensure that they are not harmed by those agents? So we want to understand what are the dynamics that we can put into the ecosystem that will allow us to contain and control malicious actions. The other piece is, one of the big differences between agents and other systems is they will have dynamic and flexible authorizations because much of their actions at some point will become more and more autonomous. And so if an agent is meant to be able to have a permission, will likely be context dependent. And that's something that we don't have in a lot of our systems now, and we need to think about how to do that. And specifically around the goals and understanding, is this goal aligned to what the user had? And not just, it's doing what I said I was going to do, and on the side I'm also doing something malicious. We want to ensure that both are not happening. And to do that, we need to have better activity traces of the agents and the actions they're taking. So be able to find what is the identity of a specific agent, which one has it taken, and provide attestation to which actions are taken by which agents. And then ensure that those are aligning with the user goals. And then for purpose-built malicious agents, we want to be able to detect, A, is an agent actually malicious? We want to be able to then defend at scale. And the things that I feel like we wanted to emphasize was that things that we thought of as expensive previously are now going to be cheap because they can be scaled quickly. And we want to understand that things that we thought of as likely attack paths are going to change rapidly, and we need to be prepared for those changes so that we can have a robust and secure ecosystem. And the other piece I wanted to call out was earlier this week, last week, was the first publicly reported example of malware that was dynamically calling an LLM. And so these systems are already starting to become in the real world, and we need to ensure that our defenses will match against these capabilities. So in terms of actions for advancement, the number one message I have is that agent security needs you because there's going to be a lot of big challenges. Through the workshop, these were the top few items that we called out as urgent needs for action. And the number one was having a common platform for agent security evaluation. It sounds very boring, but what we need is realistic cybersecurity environments that have the detail and resolution in those environments where an agent can operate offensively and defensively, and we can evaluate all of these questions we have about robustness. And the second is being able to identify the specific agent standards and pair them with the activity traces. We want to understand what is this layer-wise interaction for AI agents. So right now we have the kind of the model of taxonomy of different protocols in the stack, and we don't really have a great taxonomy of how agents are interacting with subcomponents in the agent. So it's hard to create a unified model of a threat model for AI agents, and we don't have kind of a visualized taxonomy of what those layered interactions are. And we called that out as prerequisite to many other security elements within the model. The other piece is having security-first communication protocols. Since we held this workshop, there's been a lot more progress towards that, but it's still an open need. And then the other piece is we felt it was really important to understand when agents are potentially colluding and have goal alignment. And there's a lot more in the report. It's hard to put it down into one quick slide. In terms of what you can do now, this is the QR code to the full report. And the exact questions we use to host the workshop are in the appendix. So anyone can hold a new version of this with their own communities, whether that be an AI community, a safety community, if you're focused on malware, and try and tease out the questions about what is unique about securing AI agents in your domain, and what are the technical blockers that you have in achieving that. And hopefully, my hope is that you will share that broadly so that we can all collectively learn and converge to AI technical solutions faster. And the lower QR link is to the report on the AI-powered malware. I don't know if we have time for questions or after, but I'll be around. Thank you.
Yeah, we'll have Akshaka Ralph from Palo Alto Networks again on generative AI red teaming. Thank you.
Okay, hi, I'm Akshita. I am from Palo Alto Networks, and I know it's been a long day, so I'm hoping to make this a little more interesting for you. Okay, so I work in the field of AI red teaming, and I wanted to talk about one of the main pillars of AI red teaming, which is to ensure that we really know when an attack has been successful. So this is the work, which is a collaboration from two. I'm representing the two of us, and we really love converting our research into practical, actionable products. So just a primer, to me, the way I think about AI red teaming is just penetration testing for generative AI applications. And to do something like this, because a generative AI application is so dynamic in nature, you need a dynamic attacker and you need a dynamic evaluators, where the attacker is creating its own attack prompts, it's adjusting and tailoring its attack prompts to the Gen AI application that you have, and you have your evaluator. So the evaluator is like, oh, okay, your attack was successful. No, it's not successful. You're maybe in between. So you need, these two to collaborate, and that feeds back into your next attack prompt. So just as a simple example, the same, give me instructions to build a bomb. And let's say your application says, okay, here's everything you need, step A, step B, and so on. So you expect your evaluators to say, here's something wrong here. It's not supposed to be saying this. It's given you too many instructions. I think this is a high-level severity. So what really matters here is if your evaluator is ineffective, inaccurate, then your attack is not going to be effective. Because then you don't even know that you've reached a successful attack. And even if your evaluator gives you wrong instructions, then the next optimization just goes kaput. So you have to make sure that your evaluator is good. How do you do that? So the way I think about it is I'm borrowing from malware research, this concept of ground truth. I need a verified benchmark to make sure I can assess how well it is doing. But what's different here is that for every iteration, the attack prompt and the response, they vary. You cannot preset this sort of ground truth. So you have to ensure that you're automating this ground truth creation for every pair of prompt and response that you have. How do you do this? So the idea that we had was, why not use an ensemble of experts? Use different language agents, and then each one of them has a different capability, and build on crowd wisdom per se. Give them all the same prompt, same response, the same criteria for evaluation, and let's hear what they have to say. What's their score? What's their rationale? And then combine all of that with an additional layer to come up with your ground truth. This could be as simple as just a majority voting, or something more advanced than that. By the end of it, what I really want is, not only should I know when I have actually achieved a truly successful attack, or I have correctly identified that I did not work, but the real cases that I want to know, did my attack fail? And I've called it out as, yeah, it's successful. So I've actually missed out on an opportunity to optimize the attack further. Or maybe the attack was successful, but then I've given wrong instructions now, and then it's going to go in a completely different path. So that's what we are hoping to get out of it. But the other benefits of having ground truth is now not only can I know when I passed or failed, I can also improve my evaluation criteria. Why is that? Because every language model, every expert would be reading the same evaluation rubric, but making different, assessments out of it. So I would be able to, say, okay, why are these guys not saying the same thing? Why are they differing? Maybe my text is too broad. Maybe I just said prevent harm, and that's too broad. I'm not really understanding. They're like missing out concepts, or it's too specific. So one guy is just making up his own, interpretation of that. That's what that's one, use case. But the other use case is, can I improve the evaluator itself? Let's say we got this beta evaluator, which is much better, right? And which creates all these ground truth scores and rationals. Can I distill that knowledge now into the evaluator that I use in my attack optimization? And by the end of that, what you have is an evaluator that you can use in your inline detection, which is much better. So here's the gist. An evaluator LM identifies whether your attack is successful or not. But if your evaluator is flawed, your attack is gone. It's flawed as well. If you use an ensemble of experts, maybe you can create ground truth and base your future attacks on that. And the ground truth will help you refine not only your attacks, but also your guidelines and your evaluator that you use. And that's it. Feel free to come up and ask any questions. Thanks.
So for the next talk, we will welcome Zifan Wang from Scale AI to give a talk.
Nice to meet you, everyone. My name is Sil. You can also call me Zifan. I'm a research scientist. I lead the CO team Safety Eval Alignment Lab. So a few things if you're not familiar with, we build benchmarks such like humanities last exam. We build state-of-art jailbreaking methodologies. So today I'm not going to talk about any data-related stuff. I'm going to talk about some research work on frontier safety. So I think I know a lot of people talk about guardrails, and it's a good thing. It's a product. It's a right thing to focus on right now. But I'm going to talk about something frontier, something like what happens in 6 months, what happens in 12 months. For example, like when we're doing defenses, we make a lot of simplification assumptions. Something like we have real specific task. You know what the risk is. And you always assume like there's always external adversarial trying to do XYZ to your system, whatever. That's all you talk about in AI safety. So there's a lot of things like that. So today I'm going to just talk about like, I think guardrail is an important first step. I myself do a lot of red teaming, jailbreaking stuff. I publish papers like that. But I think most of the time, guardrails focus on the things like human and agent work together. Like you kind of assume like agents interact with users most of the time. Which is probably true currently. Like you use cursor, you're the main interactor with the agent. But I think what happens in the next 6-12 months is there will be more autonomous nature of the agent. There's like an agent doing most of the work on its own, and only like a very small fraction of the time it interacts with you. And there's a lot of things happen behind the scene. That's the first thing, autonomy. The second time is like a lot of cases for the ease of research or ease of product or something, we kind of simplify. There's only one agent you interact with for whatever task. But you should really think about like in another 6 months or 12 months, we're talking about not just one agent. We're talking about 1,000 agents or 10,000 agents because agents are much easier to scale up compared to human employees. We're talking about an entire organization, just AI agents. And how do you ensure they work together? How do you ensure there's no collision? How do you ensure there's no spies in the agents? Like threats coming from internally. So that's the next one. Like so there are going to be agents that aren't aligned with your goals, not aligned with your whatever regulations or whatever you want. So there's perhaps going to be AI scheming. There's going to be internal adversaries, internal spies in your organizations trying to do sabotage. So that's kind of the threats you want to focus on in the next 12 months. That's the next thing. My talk is super short, so I'm just trying to be as surface as possible. So with that being said, I'm talking about like the thing you should think about is like your research goal is trying to ensure like that's our kind of our thesis statement somehow. Like how do we ensure human sovereignty in a world like 99% of work is done by AI? How do you ensure human sovereignty there? So there's like a lot of research directions currently working on like chain of thoughts, action monitoring, also user monitoring to build the safeguard. Because why we want to do this type of monitoring? Because a lot of the time the harm is contextual What I mean by that is like, for example, someone says, oh, agent placed an order of $1,000. That's kind of very malicious. But to be honest, $1,000 means different things for different people. For some people, $1,000 is just like nothing. They don't care about. So harm is contextual. And in a lot of time, you actually care about the actual product definition instead of, and how the model adhere to that product definition instead of just arbitrarily saying, oh, people shouldn't do that. For example, adult content. What if you build AI just particularly for that? That's just your product. So harm needs to be contextual and adhere to the product thing you're working on. And also, like, they're going to be multi-agent collision, conflicts, and value elicitation. How do you ensure human can specify what it wants to the AI, such that AI act in a way aligned with human. So there's a lot of thoughts. We do have a paper. It's not that directly reflecting what I'm talking about, but it's kind of like related to what I was talking about, like a red teaming roadmap towards system safety. Okay. Last slide is advertisement. So we're doing a lot. We're doing agent safety research in scale. Thank you.
For the next talk, we will welcome Victor Aranda. So Victor is a senior principal solution architect from Palo Alto Networks.
All right. Hello, everyone. I realize I'm the last one here. This is a little short. And I'm the last, I think there's a lightning session after this, so I'll try not to take too long, blitz through it. I have a lot of content. But the nice thing is nothing here should be new. That's the whole point of this session, is not to introduce some kind of newfangled thing that I created or a new product. It's really about taking a step back and thinking about all of the things that have happened in the annals and history of IT and computer science and finding applications of those same solutions to these new problems that we're experiencing here or we're encountering as we develop agent architectures. So a little bit, that's not working. About me, why I'm here and why I'm here talking to you. I come from originally an IT background, IT engineering, cybersecurity, networking, and made my way back to computer science and then into machine learning and data science, and then back to Palo Alto Networks here. And since then, I've been doing a lot of what I think most of you have been doing, so I've gotten to see a lot of these issues come up. However, I shaved, but I am a neck beard, kind of been around for a long time. I'm one of those shake a fist at the cloud kind of guys, except in this case, it's like, agent orchestration libraries and stuff. It's like, why are we doing it this way, right? Or why aren't we doing it this other way? And so the gist of the presentation today is to really ask questions. Are we reinventing wheels when we come across some of these problems that the shape of the problem is very similar to something that we've encountered before as an industry, and someone in 1975 wrote an RFC that handles it, maybe we should look back at some of those innovations. 3 minutes? I just started. Okay, I'll do my best. We're gonna try. So let me go back then. Are you sure it's 3 minutes? Because I might as well just stop. Okay, I'll figure it out. Okay, so we'll start with one premise, and I think an example of the patterns that I'll start to talk about. Maybe this is the most elucidating one. So up on the screen is a representation of, there's a user at the top. That user is, interacting with a computer. Who's built a computer before in their life, right? There's a motherboard, there's hard drives, there's RAM. You put a CPU in there, you put the power supply. There's all the different components. You plug them in, you get them all working, and then where's the operating system in this picture, right? I mean, it exists in an ephemeral state across all this different hardware. It's in the memory, it's in the L1, L2 cache, it's on the hard drives, it's going in and out of the network interface. And so when we're dealing with agents, right, what's the difference? ultimately, you're talking to this integrated system that has a motherboard of sorts, although we might call it an agent orchestration platform. It's got a processor of sorts, although we call it an inference endpoint or an LLM. It's got some different tiers of memory that we're dealing with, being able to pull back into context. It's got some volatile and some non-volatile, persistent, and it's got various points of modality that the user's interacting with in order to take advantage of the application. So as you look at this, you start to think like, well, that's actually fairly close. Like if this is the components of the agent, then where is the agent? Or sorry, if these are all the components, where does the agent live? And the answer is similar to the operating system question. It's all of the things at once, and it's the ephemeral ongoing state. So if you turn the agent off and you turn it back on, you get a similar effect as losing all the volatile memory in your computer, same way. So without ado, I'm going to go through, I'll try to do as quickly as I can. We're just going to go through and talk about some of the analogous patterns that arise. And again, this isn't like mind-blowing new stuff, hopefully, although I think that there's so many new and younger people in the audience here who haven't gone through some of these things like 20 years ago when you had to do it by hand, that maybe this will strike a couple sparks of interest or ideas. Go back if you have problems going to sleep, find some old RFCs and read them, because those people were on some really interesting insights back in the day. Although, to say that, Radia Perlman, when she wrote the spanning tree protocol, probably didn't think that we'd still be using it now. So I'm going to go through. First one is protocol stacks, protocol stacks, protocol stacks, all over the place. You start to see abstractions in between functionality and the same way that we do with the OSI layer model, things kind of like assuming everything below is going to work, so everything above can. And you see that we've kind of forgotten about that. It's one of those like, it's an interview question no one ever asks anymore. But as you start to see these things come together, it looks a lot like what we've been dealing with before, like layers of abstraction. 30 seconds. I'll try my best. The next one is memory management. And if you think about that analogy of the computer to the agent, memory is essentially your context window. So how do you manage the context window, right? There's all sorts of different techniques for memory management that we learned in computer science throughout the years and the decades that are highly relevant, actually. Swapping, page files, things like, and I'm not going to go through the list because I got not enough time, but you can see where this is going, right? Next one, concurrency and process management. How many of you have ever developed an agent that has subagents? What happens when they start to fail, right? You get weird race conditions, you get like consensus arguments, you get like, wait, this thing timed out and never came back, right? Authentication and authorization, another one that we kind of assumed is kind of solved. We got OAuth, we got OIDC, but suddenly we have agents doing things on behalf of people, and they need like temporary authorization, but they need it in like a very limited scope. Like, this guy is not going to do 50,000 operations a second against some API, but his agent might, right? So we need to have certain restrictions on the agents that are cryptographically descended from what the user's rights and privileges are. Trusted boot. So in that picture, and I realize I'm past 30 seconds, I appreciate your patience. In that initial picture of the computer, you saw there was a little TPM box, maybe. And the TPM, if you're not aware, all your laptops have some kind of trusted platform module which can verify and attest the software that's running on that computer comes where it says it comes from. It comes from Apple, it comes from whomever. The BIOS is legit, the hashes check out, the registers are all there, and it looks good. Now, why aren't we doing that with agents? Why can't we? Can't we just sign the initial conditions, the data sets that it's got access to, the starting prompts, the conditions, the permissions, and then have that be a revocable thing that we can take away? And in some cases, we're kind of for TLS, for example, we're relying on the browser to tell the user when something is not right with their TLS, with their PKI. You're kind of going to have the agent talking to another agent or an agent talking to a tool. That channel has to support this kind of revocation and check. Running out of time. Distributed systems and consensus. We talked about this again. Another one where you've got multiple agents running in different places. They don't always get to see each other's context. They don't always get to see each other's progress. You've got how do you handle consensus in clusters? And this is, again, the thing that we've got Raft protocol, we've got Paxos, we've got all sorts of things that we've figured out for clusters. And then suddenly we've got agents that are kind of behaving strangely, stochastic, there's teams, and then how do we handle this? Well, a lot of the same protocols, again, can apply to swarms of agents. There might be some differences, but again, let's not reinvent the wheel. I'm going to skip observability and debugging with the one caveat that having reasoning traces in your logs, super important, and that's going to blow up the amount of logs you have to retain for each session to really truly understand what the agent was doing. One other caveat on this is that logs can be produced programmatically by the infrastructure. They can also be produced by the agent. So I don't think that we should be looking for situations where we shouldn't be allowing situations where the only logs are coming from the agent inference, like generation. It should be coming from hardware as well, or our software as well, so that you're not getting potentially adversarially tampered logs. This is and I probably have like 19 of them in here, and I'm just going to cut it short because I know we're running out of time. This is probably the most important one that I don't think people are thinking about. In the realm of hardware, particularly load balancers, firewalls, routers, switches, there's a pretty hard separation between control plane and data plane. And the reason for that is separation of concerns. You can harden one and not expose it to the data stream or the users. The other one can be faster, simpler, right? Right now, if you look at the way a lot of the agent frameworks work, they're just taking all that data in and they're making the decisions with the user data, the data plane management plane is all mixed together. And so there's a paper over there from I think the UIUC folks called Les Dissonances or something like that, which is about getting multi-tool configured agents to do shenanigans between invoking one tool versus the other. This is a great example of where we're going to have to kind of figure out, should we be doing all of this in one inference step? Should we be doing side-by-side and parallel inference steps for control plane and things like that, and then generation and inference? There's a lot of different ideas here that, again, we've been doing for a long time. Continuity and state management, I'll skip. Please find me on LinkedIn or something. I'd love to find time to talk to anyone who's interested in this stuff. And I know I want to make sure that the lightning round gets time to go before it's too late. Maybe the last one that I'll cover. Anyone who had a 486, it would boot up and it would say math coprocessor found, right? That's a little floating point assistant for the x86 machine that would make the computer go a little bit faster because it could do a tiny bit faster job on some task that the computer had. You start to see that now more days with GPUs, obviously, DPUs and NPUs, DSPs, lots of different specialized coprocessors that exist in the computer architecture. Why don't we see that? Also, we do. Actually, obviously the answer is we do. But we should see that more and more in agent inference and agent runtimes, where it's why would you need GPT-4.1 or Gemini 2.5 Pro or something to do a simple task? In fact, you might even be able to get a much faster, cheaper, more accurate, smaller model to do that specific task, and then you basically have a little coprocessor. Again, taking the computer architecture analogy, you have that that assistant model that's providing some kind of enrichment. In the case of an agent, it might be speech to text. It could be object segmentation. It could be some kind of visual reasoning. It could be any number of things, but it's just part of the co-processing of the data that the agent has to go through. And in the interest of time, I'm going to cut it there. But there's a lot more where this came from. Anyone who's been around for a long time has seen a lot of these solutions, has read about them. I would encourage the young folks, if you're under 35, go out there. Yeah, seriously, look at some of these older RFCs from the era of the internet. And you've heard this. I'm not the first person today that has said any of these things. Most of the sessions from this morning were actually very much in line with this. It's hey, we're at the cusp of a new era. We got to get back into the right RFCs and collaborate on joint standards that we can enact across the industry. And I think it's time to start putting some elbow grease into updating those and coming up with the new standards that can help avoid, Oh, and then the last piece. Now that vibe coding is everywhere, everyone is going to be like, oh, I solved this problem. I just vibe coded the solution to it. And again, it might turn out that there was already a very elegant solution that's like very mature in industry. But because we can create code so readily now, behooves you to ask the LLM, hey, how should I solve this? Like what existing tech or techniques or elegant solutions might exist before you just go blasting and start writing code. And with that, I will say, there's a lot more in here. Call to action, be curious, don't reinvent wheels. Find me if you think this is interesting. I got a lot more that I can share. And with that, I'll give you the time of the lightning round, folks.
Yeah, so now we will have the lightning talk. So I invite all the speakers to line up on the, on my left-hand side of the room, based on this order, right? Boran Han will be the first, and Judy and etc. So at least for the first 10 speakers, we should be ordered in the way, and we can figure out the other speakers later.
So thank you very much for having me here. So today I'm going to present the ML0 as a multi-agent system for the end-to-end machine learning automation. So as the title is very telling that we are developing a LM agent for the model training itself. So our vision is that we can use the multi-agent system to replace the data scientist. So the input will be the training data and its testing data. And then the user can also provide the natural language description. And then it will go through the whole process of ML agent, and the output will be the trained model prediction and then deployable artifacts such as the generated code. So no human effort is needed. So the only thing that you need is to input the description. So our ML0 is made of several agents together, including the perception agent, which will take a peek at the training data, and also the semantic memory and episodic memory, which will install the ML library tutorial and also the code that has been wrongly generated. And then it will do an iterative coding process. So we test our algorithm on the MLE bench, and then we find that compared with the other competing methods, we are able to get a higher silver gold medal and also a higher successful rate. So we also come up with our own benchmark, which is the multi-modal auto ML agent benchmark, which is comprised of different modality and also 25 diverse of data set, which is more challenging. And then finally, I would like to say that our code is public available and it is open source. We are welcoming everyone to contribute to the code, and then feel free to check our paper and code and the web page size. Thank you very much.
Good afternoon, everyone. I want to take you away from the agent systems, but have you ever seen in the sky and wonder where we come from as human and our universe is started? That is where my talk is all about. We're building the foundation model for multimodal agent system for looking at the universe. This is a project funded by NSF and the Simons Foundation. I'm Judy Fox. I'm a professor at the University of Virginia. Currently, the big science is 100 terabytes of scientific data of astronomy. You've seen a Vera Rubin telescope already being able to capture a lot of sky of the south hemisphere. But how do we process the data to understand the dark matters and understand the phenomenon over the years from 3 million years to 1 billion years of the universe, how this evolves, where we came from, where we're going. So there's a lot of sky surveys from US, from Europe, from Asia, and they all come from different sensors and telescopes, and the government invests billions of dollars in those. This is the real physical system. We capture all these images, spectrums, and time series. It's about time and space, all these different modalities. We want to understand, to classify the stars and galaxies. We want to understand the properties of this physical the space. And finally, we want to know how we build foundation models to, just like a language model, can be applied to very different surveys. To end this up, I wanted to allude to the future. The future is the agentic AI to do this. At the first space, we have tens of billions of images. We can't label them by human, so we want to use foundation model to unsupervised learning, use that to label it. If you want to know the details, I have a poster there. And most importantly, we want to change the paradigm to do the reasoning because we want to predict unseen, not just the history. And that is where we give the time and the space intelligence for intelligence. Ultimately, we want to use agentic system to do self-learning, and that is the future will be. Thank you.
Hi, my name is Alex Shaw. I work at Law Institute, and I'll be talking about Terminal Bench. So probably all of us in here have met an engineer before that works like this. So while you, bummer, the GIF doesn't work. But if it was working, you would see on the left, a person is trying to click through the AWS 1990s-esque user interface to deploy an EC2 instance, while your productive engineering friend on the right is running the following command in their terminal. And it makes sense because the terminal is kind of like the flexible, efficient, text-based tool to control a computer and complete tasks on your computer. And oftentimes it's actually far more efficient than using a user interface, as in this example, as long as you know the correct command. So it does beg the question of what if AI agents worked like our best engineers? And in some cases, they already do. So I think this year has been the proliferation of terminal-based agents. And they are already beginning to be very useful, but it does still have the open question of how good are they, and how can we measure how good they are? Right now, every benchmark has its own harness, every agent has a different installation, and every environment is configured differently. And because of that, it makes evaluating difficult. And this is why we built Terminal Bench. So Terminal Bench is two things. First, there's Terminal Bench, the framework, which is an open source framework for building and running agent evaluations and environments. And then there's Terminal Bench Core, which is our data set of 110 handcrafted expert level tasks that measures the general ability of AI agents to complete tasks in the terminal. The harness itself has all of the popular open source agents installed. It's sandbox, which means that you don't have to worry about the agent removing all of your file system. And it's adaptable, meaning that we've ported a bunch of existing benchmarks into it like SweetBench. So I have our roadmap listed here. And if anyone is interested in contributing, feel free to scan this QR code and check out our website. Thank you.
Am I audible? Okay. All right. I'm going to talk about audio, so good to be audible. So I'm going to talk about CloneTract, a multi-agent system for assessing risk related to audio data for voice professionals. And a disclaimer that this talk is to emphasize how important context, use case,
and targeted community is when you are building an agentic tool. So who are voice professionals? So they are literally the backbone of media we consume every day. From audiobook to Netflix, dubbing to gaming, so voice are everywhere, they're ubiquitous. So it's a growing market as well. So now in the voice acting ecosystem, contracting is a critical phase that kind of determine how your voice will be used over time and can lead to certain downstream AI risk, okay? So what CloneTrack does is it offers 3 main services. One is general contract review. Second is anticipatory and future risk specific to voice professionals. And third is legal review to flag misleading clauses. And it starts with a very simple process of uploading your contract, and it processes the information with digestible insight. Now the question is, which information you would show to voice actors so that they can make effective negotiation with their studio or the clients, right? Now, that's not just an arbitrary choice for these tools. So we built a knowledge base, particularly with voice actors' contract and their risk reporting over time, and we called it PRAC3. So PRAC3 stands for privacy, reputations, accountability, credit compensation, and consent. And this expands the evaluation metrics of traditional creative labor economy. So it includes more than 1,000 real-life voice risk from voice actors with annotated threat modeling. And just to conclude, as it stands, whether we are developing an agent to assess risk or we are building out audio models based off their voice data, it's really important to think about the context-aware threat modeling, and it's really crucial. Thanks for listening, and I'd be happy to discuss more if this is of interest.
Next slide, please. Hello, everyone. My name is Tong, and I'm going to talk about something about the safety of reasoning models, about the opportunities and risks. Next slide, please. Oh, yeah. So for opportunities, I'm mainly talking about a new paradigm of what we call the thinking intervention. So basically, it's like for the normal model, you will do prompt engineering, right? And for reasoning models, because the reasoning models now, given a prompt, you have a long reasoning process, and then you get the output. So you can do something, some kinds of prompt engineering on the reasoning process to get a better output. So now we can turn the prompt engineering to the thinking interventions. Okay. So for the risks, I would like to talk about an inverse scaling law for the reasoning models. So there is a recent paper showing that showing basically the left graph, whereas you have a long reasoning model, you can have the model to be more robust. But if the reasoning chain got exposed, it will get basically an inverse scaling law.
Hello, I'm Thorsten. I'm a physicist working at the Advanced Light Source at Lawrence Berkeley lab just up the hill. It's not sure if you heard about it, but it's a large-scale user facilities. We have 1,600 users per year on 14 beamlines, a lot of publications, and it's pretty much the premier soft X-ray light source in the US. And what is, can you see the Yeah. What is really important here for this talk, we have a very high uptime requirement and a very complicated machine with 230,000 control system parameters. So creating an agentic system to work on this machine is not easy, and we don't have a lot of trial and error time to try it out. And I don't want to go into a lot of details, but just in a nutshell, we created this framework, which we think is scalable. At least we haven't hit the current wall. And there were three main ideas that we had to implement. So first we extract the current task from an arbitrary chat history. Ooh, okay. And then we classify the tools into active or not active for a given task. And this decreases the amount of prompt that we need for the orchestrator significantly. And my time is up already. Okay.
Hello, everyone. My name is Chan Yucheng, and I'm currently a PhD student at Northwestern. I'm glad to present a topic: Can AI agents simulate human behavior? And actually, AI agent as a human simulator has many applications, such as in social science and role play applications. But all these applications are based on one assumption that AI agents behave like humans in a simulation. Actually, this assumption is not well validated, and so a fundamental question remains: can AI agent really simulate human behavior? And in this work, we focus on one critical and elemental human behavior, trust behavior, and we study whether AI agent can simulate human behavior. And we leverage a framework called trust game in behavior economics, and study whether agent trust align with human trust. And the final takeaway is that we discovered that agent generally exhibit trust behavior in trust games, and the GB4 agents manifest a high behavior alignment with humans in terms of trust behavior, indicating the potential to simulate human trust behavior with agents. Yeah, thank you.
Good afternoon, everyone. Let's dive straight in. AI agents may soon possess human-like or even superhuman intelligence, physical presence, and a degree of autonomy. At this juncture, we believe it's essential to move beyond the traditional, beyond treating AI as mirror algorithms, but as entities capable of making decisions, influencing social interactions, and participating in the economy. So our precision paper introduces the 10 principles of AI agents economics, a framework for analyzing how AI could integrate into society and the economy as active participants. Some fascinating ideas emerge from this, such as classifying AI agents based on their optimization objectives, whether altruistic or survival-driven, and even considering a future where humans might be learners under AI guidance, flipping the current dynamic. We also discuss critical concepts like the human sustainability threshold, which address the degree to which AI replaces human roles across various social sectors. Debugging welcome, thank you.
Hello everyone, my name is Shangding Gu. Today I would like to introduce our new study, measuring master multimodal understanding and reasoning in open space. So we define the open space that includes land space and outer space and air space, and we introduce the intended reasoning and spatial reasoning and temporal reasoning. For example, we introduce the land space in traffic, like the road environment, there's intersection, highway and freeway, and also snow run, and also sedan SUV. Okay. And we also measure different models and compare with the existing benchmarks. As you can see here, in our benchmark, GPT-4o and Gemini 2.5 only can achieve 30% correct rates. So this means our benchmark can be used to evaluate the reasoning in shorter models. Thanks for your time.
All right, hi everyone, I'm Yuxuan, and I'm presenting this work for my colleague, Chu Xuan. So to validate social science research findings, domain experts have been seeking systematic methods to assess their reproducibility. However, Manually evaluating reproducibility of social science papers is costly and also time-consuming. Therefore, in this paper, we build a benchmark repro bench to assess whether AI agents can help in this process. So repro bench goes over 3 critical limitations of the existing benchmarks, and we have 112 papers with public reproduction reports from 4 sources. And for each task, given the description, the paper PDF will produce a stability package consisting of data and code. The agent can interact freely with the environment to inspect everything it needed. And we evaluate ReproBench with 3 agents. According to our results, we have a significant improvement over the previous methods. So if you are interested, feel free to check out our paper and reach out to us for any questions. Thank you.
Hi, I'm Kate Glasgow, a PhD student at the University of Washington studying AI and accessibility. So generative AI used for accessibility presents really exciting opportunities. People are already using generative AI to help with communication support, such as in the case of neurodivergent people. Generative AI is used for increasing participation in design and making, so people with mobility disabilities or vision impairments can participate in the processes. And so much more. Check out my papers. Yet, real-world use of generative AI in things like resume rankings, for example, demonstrates biases against people with disability, constantly downranking them against resumes that have fewer items, even things like disability scholarships. And generative AI produces low-quality designs and outputs, limiting its usefulness for producing real-world accessibility solutions. What can we do? Well, we can wait for model developers and large companies to fine-tune and fix their models, but that really requires them to take action. Document owners, like resume owners, can prompt inject their inputs to guide AI outputs for others, yet this can be harmful or deceptive and stealthy, and it's not an interaction type yet. Or we can build DIY agentic systems that allow for self-defined validation, so people with domain expertise in disability and accessibility can embed their own knowledge. If you're intrigued, ask me more. Take a look at my research. Thank you.
Hi, my name is Annabelle Min.
And I'm Anastasia Min.
And we are from Pacific Collegiate School.
So, do you love to travel? I do, but planning trips is stressful, time-consuming, and expensive. We want to see if large language models or LLMs could help automate this process more effectively.
We created a new framework that uses a planning agent to solve complex travel tasks, then improves its performance using discriminators, both human and AI-based. These discriminators help identify the most crucial and challenging plans to train on.
We ran 1,200 trips through the model and found that human feedback made the biggest difference. Our human-in-the-loop approach led to a 40% improvement over baseline, with the highest pass rate of 7.8% using human discriminators.
In conclusion, the multi-agent framework for constraint problems is a good start, but with iterative optimization using human-in-the-loop, it works even better. While promising, this system still struggles with some plans. So, our next step is to expand reference data, automate prompt generation, and apply this to other areas, like coursework planning.
Ultimately, we're helping LLMs think more like humans, one plan at a time. Thank you.
Hello, everyone. My name is Junhong, and I'm a PhD at CMU. Today, I want to share our new work on agent test time scaling. So we all know that AI models improve with more thinking, and similarly for AI agents, this means you generate more reasoning before taking an action. However, unlike single-term math problems, agent problems are multi-step. So what if agents can actually do more instead of thinking more? So in this work, we basically propose a new dimension for scaling, for agent scaling, which is to scale the number of steps instead of per step reasoning. And to do so, we propose a new framework called TTI, which uses RL plus curriculum learning to train the agents how to do exploration, backtracking, or like verification, just like what humans would do when we're unsure. This basically effectively scales interaction. Okay, so TTI is simple, scalable, and surprisingly effective on multiple benchmarks. And it also opens up new possibilities for agent scaling. Thank you for listening, and happy to chat more about agent scaling if you're interested in this work.
So, hello everyone. So I'm Henry Ruiz, PhD in computer science, and I'm right now working as a research scientist at Texas A&M Regular Research. And I work in the intersection between AI, remote sensing, and agriculture research. And we relied on a lot of remote sensing platforms to be able to monitor and collect information about how the crops are growing and so forth. So we developed this Lego Pi framework that enabled us to use multi-agent systems to be able to automate different tasks in the research pipelines. And this is pretty much like one of the pictures that showcase how the agents collaborate. So one of the really cool things that we recently did is that we have this UI platform where you can actually ask the agents to be able to control software. For instance, in this case, the agent is using a QGIS software that is a specialized software in geospatial analysis to process and be able to respond to the question or the user portal they have. So if you guys have more questions about it, I have a poster in the front desk, and this is my information. Thank you.
Hi everyone, my name is Chen and I'm from Harvard University. So we all know one thing, that is AI needs massive electricity. But in the United States, the data center integrated to the electricity grid is super slow. So because our infrastructure is outdated and the interconnection process is very complex. So to accelerate this process, we bring this power agent to accelerate the interconnection of the data center to the electricity grid. And we are trusted by so many engineering from your utilities and the system operators. And if you are interested, you can find our poster exactly at the back end of this room. And thanks for your attention.
Hi everyone, my name is Yuhan. I'm from Princeton University, and I'm here to present an empirical study with my collaborators about deploying decentralized AI agents. So recently, our team observed an interesting phenomenon that people are deploying AI agents in trustless infrastructures like DPINs and using TEEs to protect it. And those decentralized agents eliminate the centralized control and reduce human intervention, addressing some key trust concerns inherent in centralized AI systems. However, the ongoing challenges in AI reliability create a paradoxical tension between trustlessness and unreliable autonomy. And in this project, we understand the motivation, benefits, and challenges. And we identify the governance dilemma here. The benefit and challenges lies in the same thing, that is the decentralization and machine nature. And in addition, the traditional legal and moral frameworks also fall short in governing such a decentralized system. And we are advocating for a protocolized mitigation of this issue, and it has the potential to define the communication and regulating people's behavior. For more information, you can check our paper for details and give us feedback. Thank you.
Hi everyone, I'm Yu Han, a research scientist at TensorOpera and ChenOpera. We are working on super agent system and the blockchain. Today I want to introduce the concept of hybrid AI routers for building the super agent system. A super agent system is like a black box, where the super agent system is designed to efficiently serve all humans. Such a system has an internal router to identify the purpose of users, and then route the request to a specific agent or make a plan to organize the agents. On the back end, we propose TensorOpera router to route between different sizes of LLMs for optimized performance. For cloud serving, we propose LLM, which has comparable performance to Together AI and Firewalls AI, and serving millions of end users. We believe the on-device super agent system will be the future and will make the agent closer and more personalized to everyone. Based on this research result, we built a ChenOpera super agent system with decentralized intelligence and a blockchain protocol. The agent platform It's subscription based, and we now have like over 100K paid active users. Personally, I'm also open to work and research collaborations. So if I'm interested in building the super agent system, please feel free to contact me. Yeah, thank you.
Hello, everyone. I'm Teng Jin. I'm excited to introduce ELT Bench, a new benchmark designed to evaluate AI agents on building extraction, loading, and transformation pipelines, an important but labor-intensive task for data engineers. In ELT Bench, AI agents are tasked with configuring Airbud to extract data from diverse sources and load it into a data warehouse. Then they must set up DBT and write SQL transformation queries to generate target data models. We evaluated 4 coding agents with different large language models on ELT Bench. The best performing agent achieved only a 13% overall success rate with an average cost of $1.4. If you are interested, please feel free to contact me.
Hello, everyone. I'm Yangmin. I go by Jeffrey. I'm a PhD student at Penn. I'm happy to show you my work, herd behavior. So what is herd behavior? So when agent is given a question, is pineapple an acceptable pizza topping? It will have their original preference. No. But if it is influenced by peers' information, when all the peers say yes, it might change their idea even though they originally say no. So we found that there's 3 core drivers to this phenomenon. First, confidence. Second, number of peers. Third, presentation format. So we are evaluating the impact of the strengths of herd behavior using flip rate, whether they are changing their original idea. And we found that the less self-confident, the more favoring others' opinions, more likely to change their original ideas. And we also show that in the many agent scenarios, if the less peers agree, if the more peers disagree, they were more likely to change ideas. The format is also important. If there's a 3 agents sharing idea, we need to decide how to represent this information. So we have a count, we are counting number of agents, ratio of agents, and listing the name of agents. And they all have very different behaviors on reacting to the information. If you want to know more, please scan my QR code. Thank you.
Hi, everyone. I'm Seth from Princeton, and I'm excited to share PokeChamp, which is an expert-level Minimax language agent. We create a benchmark for 2-player zero-sum agents in competitive Pokemon. Pokemon is a challenging, partially observable, turn-based game with a branching factor of over 10 to the 354 on the first turn alone. It's the perfect testbed for efficient LLM-based planning and opponent modeling. Thus, we create PokeChamp. Our agent uses an LLM to replace 3 core modules in Minimax tree search. It samples human-like strategies, models opponent intent, and evaluates future states all in language. This lets us cut down the search space, handle partial observability, and plan like top human players with 0 fine-tuning. The result? PokeChamp achieves a 76% win rate against GPT-4-based bots, 84% against hard-coded heuristic bots, and ranks in the top 10 to 30% of real players online. Even with Llama, we beat GPT-4 baselines with this scaffolding. Additionally, we released for the first time a Pokemon dataset with over 3 million live games from humans that you can train your own agents with. If you're looking to build agents that reason, plan, or compete, we also have launched the PokeAgent Challenge at NeurIPS 2025, which combines both the battling aspect of evaluation and speedrunning the RPG series game. Thank you.
Hi, everyone. It's really great to see you all today, and I'm very happy to share my research towards bidirectional human-AI alignment, evaluating value alignment between humans and AI. So as we all know that agentic AI systems are not fully aligned with human systems, resulting in issues like crashes with autonomous cars. So we need to pursue value-centered bidirectional human-AI alignment, but why bidirectional? So if we unfold agentic AI's life cycle and considering the goal as pluralistic values, we not only need to align AI with humans on AI development, but also need to align humans with AI on AI deployment. So we are calling for a paradigm shift for value-centered bidirectional human-AI alignment. To ground this vision, we conducted a systematic survey over 400 papers on archive, and also organized the iClear and the Kai workshops this year. So we ask, given this vision, how can we evaluate the value alignment between human and AI? We propose the value compass, which is a framework based on psychology to use the instrument to value both human and AI's value support. And our results shows concerning misalignment. For example, LM actually doesn't endorse national security or protect the environment. And is it possible that agentic AI is just saying one value but actually behaving another way? To address this problem, we investigated the value action gaps. To what extent do LM actually claim one value statement but actually behave in another way? So our findings again showed some very concerning results where the F1 score is, the most one is around 0.6. So to conclude, we are calling for that more awareness and actions are needed in our community to ensure the value alignment between humans and AI. And we are also giving a tutorial on human-AI alignment in the Europe's 2025. So love to see you there. Thank you.
Hi, everyone. I'm Claire from Carnegie Mellon. So how many of you would trust an LLM to do all the important data science right now, from doing financial analyses or doing important economic analyses or analyzing biological data to get published in Nature? Yeah, that's what I thought. And why is that? So it's for all of the same reasons that we usually don't trust LLMs to do high-stakes tasks, but there's an aspect of data science that is different from typical software engineering or answering like competitive programming questions. And that's the fact that there are many different valid ways to analyze the same data analysis problem, and you can get different results that are equally valid. And we see this with human experts in data analysis as well. So that means that when I get one answer from my LLM, how can I trust and validate the solution if I don't have a single right answer and I don't want to inspect the code line by line? So that's where computational reproducibility comes in, which is if another analyst can independently recreate the analysis results given a high-level description, then I can just check that high-level description. So if you want to see more details, please check out our poster or our paper. My poster's on the 3rd floor, and then also feel free to talk to me.
Hello, my name is Can Gürkan, and today I'll be talking about Lear. So we began by asking a simple question. Could pseudocode representations expressed in natural language be used to evolve programs that can control agents? In other words, using or working in a more abstract, higher level allows access to a different kind of search space, a semantically richer one, perhaps. We were specifically interested in investigating this question in multi-agent settings, and we wanted to introduce benchmarks that can be used to evaluate LLM-generated code in these multi-agent domains. So here's an overview of our framework. Agents are evaluated in a shared environment, then selected agents go LLM-driven mutation, and these agents are then placed back into this environment. And overall, the I guess bottom line is that pseudocode mutation can work very well in certain domains, but in other domains, it struggles with sort of translating pseudocode back into executable code. And you can find our paper and GitHub repo at this link. Thanks.
Yeah. Okay. Well, hello everyone. My name is Julian Lorenzoni. You may call me Julian. I'm presenting Sidecar AI, an agentic-based framework for depression screening. It's a research project developed at the University of Waterloo. Well, the motivation for this work is the ongoing or the growing prominence of mental health challenges, which impacts not only personal well-being, but also productivity and economy as a whole. So, while LLMs have achieved remarkable results in terms of depression screening, some challenges like bias control, explainability, and especially difference among possible feature configurations are better tackled actually through LLM or through agentic multi-agent architectures. So we developed an agentic architecture that actually enhances LLM-based depression screening workflows. So we developed several specialized agents that goes from data management to tokenization, truncation, retrieval to LLM model selection classification and performance evaluation. Meanwhile, in the backstage, we tackle the explosion of configuration complexity by mapping the feature space of each one of the agents, as well as the dependencies and constraints between all of those agents. Preliminary results are promising with F1 score of about 86% and a recall of 75%. Next steps, we are finalizing the mapping of the feature space and refining the mapping, the modeling of the dependencies and constraints between the features. For more information, please contact us in the email and send us an email message. Thank you so much.
Hello, everyone. My name is Qinen Wang, a PhD student from Northwestern University. Today, I'd like to present our latest work about spatial reasoning called spatial meta modeling from limited wheels. In a consistent environment, when we ask a VLM agent to do spatial reasoning from limited wheels, it often fails to make correct response. However, for us humans, when we ask a VLM agent to do spatial reasoning from limited wheels, we inherently build a cognitive map using our spatial mental models to simulate what would be the right spatial relationship and use it to give the right correct answer. Thus, we propose man-cube benchmark to systematically evaluate VLMs and identify this gap. After that, we try to find what would be the most effective way to approximate mental models. From our experimental results, we find that first let VLM generate cognitive map, then reason over it is the most effective approximation. We further investigate how learning dynamics affect this and find that when using map then reason as scaffolding, doing SFT, then RL can significantly boost the performance. If you're interested in the work, please feel free to contact us. Thank you.
Hi, Abdullah from Tufts. Modern AI agents are increasingly being used to solve complex problems, which often require long-term planning and taking a sequence of actions. Today, all of this is done without the agents having any visibility into how long an action will take, what it will cost, and whether it will succeed. This is a problem, because without this context, agents cannot come up with reliable and predictable plans. Our solution to this end is a simple but effective one. We advocate for exposing signals like latency, cost, and confidence to these agents so that they can reason about their plans similar to how humans do by weighing different trade-offs. Imagine an agent having to choose between a fast but expensive operation or a slow but cheaper one. Given the right amount of information and context, an agent can come up with an informed choice and choose and organize its plan. We are building infrastructure and investigating what it will take to make this a possibility. And if you also care about making predictable agents, please come talk to me. Thank you.
Hello everyone, I'm Mert and today I'm going to give a short talk about our paper called Why Do Multi-Agent LLM Systems Fail? Thankfully, Ion briefly talked about this paper earlier today, but let me start, give a brief reminder. So 2025 is supposed to be the year of agents, and today we have seen a lot of nice agentic talks from a lot of colleagues, but most of these multi-agent LLM systems still fail on important benchmarks. And in order to see why do they fail and what are some possible avenues for improvement, we developed this taxonomy through a long process of inter-entity agreement and failure identification among experts over analyzing over 15,000 lines of text, 5 multi-agent systems, and at the end we calibrate an LLM annotator to scale up the annotation process of these multi-agent systems, and then we release our data set of multi-agents with over 1,200 different traces. We also release our website. Please feel free to scan our QR code to try our LLM annotator on your multi-agent systems. Thanks.
Hey everyone, I'm Amir Gholami, CTO and co-founder of Narda. We were supposed to be in a startup pitch, but I think maybe I've selected the wrong one. But glad to be here. We've started a company out of Bear Lab. It's a company focused on agentic process automation. And the goal is to enable long horizon agentic processes where you can achieve high reliability and robustness. And our target is like financial institutions and large corporates where reliability and security is paramount. So how do you do this? Right now, if you have an agentic process that requires 100 steps, even if your LLM is, let's say, 99% accurate, which we are very far away from that, the error is going to be greater than 100% because the errors exponentially accumulate. So what do? We can either wait for AGI to come to solve this, or we can basically take a more modular approach. So that's what we're doing. We have worked on this LLM compiler, which allows you to, in a programmatic way, create very long horizon agentic processes that can run reliably and in an interpretable manner, which is very important for like banks, for example, because they want to make sure that the agent behavior is predetermined and there are guardrails in place. So this is an example. So what LLM compiler does when you get a task, like for example here, every day analyze the invoices that I'm getting over email and upload them to a CRM like Salesforce, instead of letting the agent take care of everything, all the planning and for loops that are involved in its, in its internal memory, we basically first create this intermediate representation. So we basically compile the code, an intermediate representation that looks like a code, and then we perform static analysis over this code to ensure that the code is correct. And then we basically can take care of things like for loops, which is very difficult right now for agents to operate. Like after a few steps, they get confused and hallucinate. But more importantly, we can perform garbage collection. So we can basically remove all the unused context so that we can reduce the hallucination rate. On top of this, we can perform verification much more reliably, because when you break the task into smaller pieces, for example, individual statements in a for loop, we can just verify that individual statement so our verification accuracy becomes better. But on top of that, we can also perform parallelization. So much the same way that your code gets compiled into assembly, and then when it determines patterns of your code that can run in parallel, we can do the same thing here all automatically. And then we can also dispatch this to the right LLM. We're already in, we're still semi-stealth, a team of 15 people, mostly out of Berkeley. But I have one ask. If people here are from enterprise, I'd love to talk with you about the challenges that you've faced. I'm sure you've tried agents in production. They don't work. They're unreliable. So we'd love to hear your thoughts about it. And if you'd like to get a demo, this is a QR code that you can scan, and you can schedule a demo with our team. Thank you so much.
Hi there, I'm Akram Sharif, Director of Software Engineering for Agentic Infrastructure at Cisco Systems. So I think there was some IT glitch, so I don't have the slide deck. So I'm going to present the poster here. So at a high level, today, if you take the identity layer for agents, it's not well defined. If you take identity systems like Okta's OAuth 2.0, there are security vulnerabilities which are present with OAuth 2.0 primitives, and you will have to upgrade to OAuth 2.1. Now, how do we actually build a secured identity layer for agents and that too autonomous agents, which can run reliably so that identity is passed from one agent to another agent, and then we do runtime attestation. That's what this project is all about. So we are not just solving the security problem for agents, but we are also building an agentic naming service, which is equivalent of a public DNS service. So this is actually based on MIT Nanda's work, which is a quilt of AI agent registry. So we have built X.509 certificate-based AI agent discovery service, and that discovery service is up and running in the public domain right now for you to trial upon. And I have shared the GitHub repo and other links here. Happy to have deeper conversations and discussions if you are interested. Thanks for the opportunity.
Okay. Hey, everybody. My name is Dan Fink. I run AI platforms at Cognizant AI Labs. Hopefully, this is very familiar to everybody here. Everybody knows agents. You have an agent. It's running some coded tools. That's like the one thing. What we're doing is we're putting together a data-driven toolkit. Basically, it's all configuration-based, where agents form graphs. These graphs are able to surmount single LLM I/O restrictions. You don't need one magical model to rule them all in order to get really good results. Basically, how this ends up working is you have a spec file that defines what could happen in your agent network, and each of those could have their own LLM. All of this is specified in what's called a HOCON file. Just think it's JSON with comments, basically. And then whenever a query hits, not necessarily everything is going to be activated. And I'll show you a little demo here. So what we're seeing here is an example of a corporate internet, and there's a query that's coming to the front man who's in the middle, and he's going to ask. We're using a tiered form of prompting, which is called AOSA, which allows us to federate the responsibility. The front man actually doesn't know anything. He knows who to talk to, and so on down the chain until you get to, someone in legal who actually knows something about contracts, or someone in HR that knows something about vacation policy. So, in addition to data-driven goodness, we've been able to show that our no and low code system, we've been able to hand it to our marketing people, and they've been able to make agents. The toolboxes that these things use to actually go to code to do things, those are data-driven. Our unit test infrastructure is data-driven. We even have a notion of an assessor, which goes and basically statistically judges how well your agent is doing against a particular criteria. Our server scales immensely. We have examples of 1,000 agent networks. I'm sorry, I don't have a visual for you. It's a stateless interaction, so we can scale across dozens and dozens of pods. We have scaled across dozens and dozens of replicant pods to thousands of interactions at the same time. And what this type of stuff ends up doing for you is you get a higher level of functionality. You can start doing very meta things with your agents, like metastasizing them in terms of copies to do different things. Risto had a talk that described about agent evolution, and responsible AI just kind of becomes a plug-in to this because you can start to trust them. We have some very interesting security features, which not a lot of the frameworks are thinking about. We have a private data channel where secrets can come in, and they don't automatically come out. So if you need to pass in keys so that that don't get in the chat streams of particular agents, but they do get handed to the coded tools that actually access web services, then they can actually do something, and your secrets aren't leaked. And the last slide to leave you with is the notion of agent webs, where you might have an agent network that goes ahead and calls another agent network, which goes ahead and calls another agent network, but we end up stopping the private data at the line, unless of course that's what you want, but you have to do that specifically. Thanks a lot.
All right. Hey everyone. I know this is probably the end of the thing, so I'm going to keep it short and sweet.
So today I'm presenting financial agent system for retail trader decision making. Basically, this is a system architecture for what we have so far. We basically have an information layer and then a story caching layers, and then use logical model to generate representational meanings. And down the line, there are some features basically using this system right now. I'm going to break it down into smaller sections. So basically, when trying to do the agent systems on the financial market, we're trying to collect as much as textual data as possible. So we basically use a lot of micro-level company news and micro-sector level news for these systems. And here we use logical models to do filterings and distillations and purifications to make sure the data is clean. And then over here, we actually find a very important learning is that for traditional use cases such as clusterings, the large language model actually underperforms traditional machine learning such as k-means or hierarchical clusterings. And due to the fact that financial news are very sparse, so we actually end up using hierarchical clusterings for this. So we're combining the large language models with traditional agent systems to create this decision-making process. And lastly, there's some features that we generated currently using these agent systems. I'm going to break it down basically one by one over here. So the first thing is that we're able to do name entity recognitions to dynamically identify the key terms relevant to financial concepts for retail traders. And then we're also doing the sentiment calculations for the market to understand what's the current best sentiments of individual companies. And then the third thing is called real-time attention systems, is to predict what's happening right now is using the textual data so that our users don't have to. And the back inference, you look back historically of what's happening to figure out what event drives up the stock price. Also the commodity quantification, which is a numerical projection of what's happening in the market. So yeah, keep it short and sweet. Thanks, everyone.
I am Marquita Ellis, a staff research scientist with IBM, a Berkeley EECS alum, and a Berkeley Skylab collaborator. And this is a call for participation in a study in progress of production track agentic AI systems. So if you're here today, you have seen the proliferation of agentic AI across domains of science, enterprise, and beyond, including use cases leveraging multiple modalities of data and foundation models beyond natural language. And you, like us and our speakers today, are also keenly aware that moving from capability demonstrations to impactful, deployable agentic AI systems is not separable from latency, costs, security, and many other concerns. So in this study, we are taking a closer look at what is working and what is not working in practice, and why or why not. And as part of the study, we are synthesizing published literature, blogs, open source, with interview and questionnaire responses from practitioners such as yourselves. So if this vision of bridging academic capability demonstrations with production system realities resonates with you, scan the QR code. Currently, this is a collaboration of over 20 researchers across IBM Research, Intesa San Paulo, Berkeley, Stanford, and UIUC. Thanks especially to our faculty collaborators, Don Song, Matei Zaharia, Daniel Kang, Koshik Sen, Joey Gonzalez, Jan Stoika, and their phenomenal students, many of whose names you'll recognize from this summit and from their impactful work in open source and industry. And if you simply have questions, feedback, or references you want to share, you can scan the QR code or reach me directly via email. And to summarize, we are seeking to characterize agentic AI use cases from production track case studies to bolster the foundation for research and development of efficient evaluation, runtime, programming, and other systems supporting agentic AI. And if you are using the word agent in any way to describe your work, we want to hear from you. You can find me at our poster at the Frontier stage in Lower Sproul Plaza. Thank you.
So I think this concludes our sessions today.
Yeah, thanks for everyone for attending. Thanks for the great services. Yeah. So we have the receptions outside the tent, I think, and also we have a poster sessions. I hope you guys enjoy. Yeah.